So I think in the paucity of time, we will start. Good morning, everyone. Welcome to this first edition of the Zak World of Façades conference series here in Chicago. A little late to the party, but I'm sure it's going to be a great event. I quickly introduce this event to you. Since it's the first time here, I quickly take a few minutes to introduce this event to you. My name is Ahmed. I'm part of the organizing team here at Zak. We started this event back in 2012. We started it as a small networking event. Events grown across the globe. We've completed around 143 editions as on date. This is edition 144. This is our event lineup for 2024. So we are all across the globe, 38 completed countries, right from New Zealand up until Canada. Facades are designed, engineered, installed differently in different regions. So for us, it's a challenge. It's exciting to present facades, to present stories of people designing from different regions, the way they look at facades, the way the energy codes are, the way the fire codes are. So it's a very interesting affair for us organizing these events. It's kept us motivated to go from strength to strength. In North America, we are present from 2018, initially with a couple of events in New York City only, but then we expanded to other cities in the US, and finally here in Chicago. Should have been here much earlier, but I think all good things take time. We have a great program for you today lined up. I'm sure you're going to enjoy our storytelling from our speakers today. So this is our 24 lineup, as I said, spread all across Europe, Middle East, Asia Pacific, North America, and the story keeps going on and on. These events wouldn't be possible without our event partners. I'd like to thank them for supporting the events. So for this Chicago edition, our presenting partner is Rainers Aluminum. Rainers is a Belgian company. They've got aluminum door, window, curtain wall systems. They're one of the leaders in their domain of system windows, doors, and facades. So they have been partnering with us consistently in the North American region and now also in Europe and other parts of the world. So they are our presenting partners. I'll introduce our associate partners, starting with American Fiber Cement Cladding AFC. They are, as the name says, a fiber cement cladding solution provider. Archon Glass is from Germany. They've got some value-added glass products, bird-friendly glass, other fritted glass, and other value-added glass products. Axalta is a leading coating manufacturer of liquid and powder coatings, formerly part of the DuPont group. Boston Valley Terracotta, as the name says, one of the leading terracotta suppliers here in North America. Bricks Incorporated, another leading brick manufacturer and supplier. Cosentino, again, we know them as a tabletop company, but they've got an engineered synthetic stone product made out of quartz and ceramic called Decton, which is now being used on the facades as a cladding material. Clad, slate cladding, Spanish company, again a very interesting product being used in commercial projects a lot now. EOT, German company, they've got fixing systems and they've got rain screen cladding attachments and systems. MSeal, part of the Sika group, they've got they've got the expanded seal and joints solutions. Envilon is our associate partners. They are from Germany. They've got BIPV solutions. Equitone, Belgian company, they've got fiber cement cladding solutions. ES Group, they've got windows, aluminium, UPVC, glass processing, pretty popular here in this region. EXO is a distributor of some cladding products, terracotta, fiber cement, and other value-added products. Griffin Glass and Metal Works, one of the local glaziers and fabricators here from Chicago. Guardian Glass needs no introduction, world leaders in coated glass solutions. HB Fuller, Comaling, sealing and bonding solutions for insulated glass units. Janssen, Swiss company, world leaders in steel door window facade profile systems. Longword, again, American company, they've got a lot of interesting cladding products made out of aluminum and other materials. Northern Façades, part of the Flynn group. They've got attachments, fixing systems for rear ventilated cladding solutions. Optimum is one of the fabricators of steel windows. Pole, German manufacturer of rain screen cladding solutions and other bespoke high-end solutions for facades and cladding. Schildan Group, distributor of the molding terracotta, so again one of popular products here in this region. Telling, distributor of Wienerberger and other cladding products. And of course, this event is certified by AIA for 8 learning units HSW credits. I think when you are leaving the venue at the end of the day, you can just sign up the sheet, which is at the registration counter on top. Just to give you a quick brief of the events which we are doing recently. So our next event is in Los Angeles next week. We've got our first 2-day event which we are exploring in a newer format, in an art show kind of format in Dubai, which is at the Coca-Cola Arena. So it's a bold new format we are trying after 140 odd editions with awards, workshops, and conferences. Everything is big in the Middle East. There's lots happening over there. There's a lot of momentum. There's a lot of construction happening there. So we thought we'll do something on a very large scale, very bespoke, artsy kind of feel over there. We're also doing our awards, which is basically rewarding excellence in facade design and engineering. And then we go to Miami, we do Toronto, we do Austin, Vancouver in October, and then our biggest one in the region, which is basically New York City, 600 plus event. So this is what we've been doing with these events. It's been great for us organizing these events in different parts of the world, getting different people to come and tell their stories on design, engineering, and installing facades. So a couple of housekeeping rules today. We won't take any questions. If there are any questions, you can ask our speakers directly in the networking breaks. The tea, coffee, and lunch is being served on top. The way this venue is designed, the women's restroom is here on the 9th floor, and the men's is on the 10th floor. So you will have to use the men's on the 10th floor if you wish to use. You can use these lifts to go up, or you've got a staircase here via the women's restroom to go on top. We've also recorded today's event, so those who wish to see the recordings, you'll be given a YouTube link a week from now, where you can access all the recordings of the presentations. We have permission to share it with you. So that's it from me. I'd like to take your leave, but you'll be in able hands. I'd like to call upon Lori Day from JGMA. So she is our event host and convener for today. She'll be taking you through the end of the day, introducing our speakers. And I hope you enjoy today's event. We've got some nice topics being presented. And enjoy, have a good day. Lori, over to you.
Thank you, Ahmed, and welcome everyone to this incredible inaugural event in this incredible venue and this not so incredible day in Chicago. I'm so honored to be here. It's so exciting to see all your smiling faces. I see lots of friends in the industry, people I've worked with for years, so I'm so excited to connect with all of you. It's really fantastic that we have an event like this where we can come together, connect, learn, network, and celebrate design. And I have to say, looking around, this has got to be the best selection of eyeglasses I've ever seen in one room, I have to say. So again, as I had mentioned, my name is Lori Day. I'm a design principal at JGMA. For those of you that aren't familiar with our firm, just give a brief overview. We're a community-focused, mission-driven firm. Behind me is a sample of some of our work, and I'll just touch on a few highlights. We're leading the T5 O'Hare International Terminal design. It's the largest contract won by a minority firm in the history of the city of Chicago, so that's very exciting. Been working on that for a long time. A few others, Humboldt Park Wellness Center. It's aimed to help combat health and nutrition challenges faced by the Latino community. And also Pioneer Bank, we won through an Invest Southwest competition at the bottom here. or rehabilitating a vacant, kind of landmarked building to become a cultural hub in our future offices. So enough about me, back to the conference. As Ahmed mentioned, this symposium marks the 144th global event and first time here in Chicago, which is really exciting. Given Chicago's rich history of design ingenuity, as we all know, it's about time this event landed here. And might I say, the architectural capital of the US and maybe the world, in my opinion. So I don't know about you, but this is the first conference I've been to that focuses solely on facade design, which is, as you know, very critical to any project and the success of the design. Beyond simply protecting us from the elements, facades contribute to the urban fabric of our cities and shape the aesthetics and functionality of our urban environment. And for anyone that's designed a facade, you know it's an infinitely complex task that requires so many facets, blending of form, function, aesthetics, technology, sustainability, ingenuity, and patience. So I'm excited today to learn from all of you and from all the panelists that will be presenting their projects. So for today, we have an incredible program planned with unique speakers here to discuss a wide range of topics about the latest technological innovations in high-performance facade design and fabrication and installation, to give some highlights of some of the cool topics we're going to be learning about. We're going to learn about exploring sustainable facade solutions using carbon-neutral and low-carbon materials, using virtual reality to redefine the design process, repositioning existing facades, and ideas for creative adaptive reuse. And we have a slew of really interesting case studies I hope you can listen to. For instance, the MIT Schwarzman College of Computing, UC campus facility in 800 West Fulton by Skidmore and Zamero, Salesforce Tower Chicago, better known as Wolf Point South by Pelli Clarke, 1000 South Michigan by JAHN, the Silvio J. Molo Federal Building Facade Repositioning by Krueck and Sexton, who also designed this beautiful facility that we're in. And finally, please don't miss, at the end of the day, this will be really exciting, the Obama Presidential Center by Todd William Billy C. And they'll be kind of talking through the storytelling of the facade design and how that came to be. So, don't want to talk too long, so we're going to go ahead and kickstart the day with a discussion on how commercial buildings contribute to the vibrancy and activation of the public realm. Our first speaker is Joachim Schuessler. He is a principal at Goettsch Partners, who we all know is a firm acclaimed for designing very innovative high-performance buildings. So please, let's all give a warm welcome to Joachim.
Thank you. Good morning, everyone. Thanks for coming. I'm going to talk today about a project we have finished here in Chicago recently, 320 South Canal at Union Station. I'm going to talk about two topics. We have a pretty interesting lobby wall and how transparency impacts the public realm, as well as a media art piece that enhances a pedestrian experience. I wanted to shout out to our client, Riverside Investment and Development and Convexity Properties, that we've done multiple buildings and worked with. For us as architects and working on those buildings, it's very important how a building meets the ground. Even though these are tall buildings, they impact the skyline of cities. It is very important how a building impacts the ground. So you see a couple of buildings here that we have been able to work on in Chicago, 111 South Wacker, 150 North Riverside, and 110 North Wacker. And you can see a reoccurring theme of transparency and how to make indoor and outdoor spaces connect them, how to provide as much open public space to the inhabitants of the city, etc. And that's a theme that is kind of weaving through this project I'm going to talk to you today about. So here you can see a site plan. So you can see the Sorry. The building is located, or you have an almost one city block site. The building is located on the east side of the site, just south of Union Station. And you can see a large park space on the west side of the project. It's a 51-story office building with some amenity spaces. And here you can see some pictures. On the left, an image at Canal Street looking south. You can see the setbacks of the building as elevator cores drop off. And then on the right, you can see the building, and you can see the large park facility next to it on the west side. In the background, there's Union Station. This is a site plan just to highlight two areas I wanted to address today. So in yellow, you can see the enclosure wall of the lobby. And in red, you can see the art sculpture that is basically at the underside of a pass-through that's connecting Canal Street to the park. You can see the other elements of the building, the elevator cores, obviously. There's public functions, restaurants, a banking facility, and a bar located on the ground floor, together with the lobby, and obviously the large park on the west side you can see here. But diving into the lobby wall, which is one of the most transparent, exciting walls I have worked on, you can see here an image of the building looking from Canal Street towards the building. You can see how we transferred the perimeter columns into bundled V-shaped columns to open up the ground floor and create this tremendous 90-foot long or 90-foot wide open space. And in the background, you can see the glass wall. Collaborators on this project were Stutzky Engineering that collaborated with us and the engineering of the wall. Clarke Construction was a general contractor. New Hudson Façades did the entire enclosure for the building. And Lynda Façades did specialty engineering and procurement, etc., for the lobby wall. Here you can see a detail. Looking at the lobby wall, you can see the glass pieces are 10-foot wide, 40-foot tall, and you can see the very transparent entry conditions. So as we were developing this system, this wall, we had a couple of aspirations and goals in mind. We wanted to have as much transparency to blur the boundaries between interior and exterior space, to minimize sidelines and joints, minimize connections, use as much hidden connections as possible, and develop a system that was efficient for installation. On the left, you can see two elevation drawings that outline two different ideas that we investigated in the early stages. On the top left, a system that has 3 vertically stacked panels, and at the bottom, a system with one full-height single glass panel, 10-foot wide, 40-foot tall. In the end, that was the selected system, and we did a cost comparison. The systems were equal in cost. From an installation perspective, the system that was selected was much faster and offered some other opportunities. And as architects, we were very excited to have the opportunity to work on a system which is one of a kind. So here you can see some of the build-ups of the different pieces that make up the system. So we have a face glass, as I mentioned, 10-foot by 40-foot tall, weighs about 6,000 pounds. The face glass is made up of 3 lights. There is an 8mm outboard light, a 10mm center light. They're all low iron, heat strengthened Pilkington glass, and then another 8mm outdoor light. So both the indoor face and the outdoor face have an OptiView anti-reflective coating. So the external reflectance of the face glass is about 2%, which is very, very low reflectance, 89% light transmittance. And then on the left side, you can see the buildup of the glass fin that that works in combination with the face glass to make it structurally feasible. The glass fin is 2 foot wide, again 40 foot tall, and you can see it's made up of 4 lights of 12 millimeter low iron heat strengthened glass, approximately 50 millimeter, 2 inches build up for the fins. Here you can see initial mock-ups that we tested certain conditions. As I mentioned, we wanted to minimize the sidelines as much as possible. At the bottom left, you can see a drawing showing the typical conditions, how the glass fin meets the face glass. And I'll dive into this in a little bit more detail, but we wanted to understand visually how does a joint look, how can we minimize that. So on the right, you can see some images of mock-ups of the joint condition. Initially, we thought introducing a lighter frit would actually help us to minimize the joint condition. In the end, we selected to go with a dark frit, hiding some of the silicone that glues on some of the channels to hold the pieces together. Here you can see a basic system overview. So you can see the bottom connections of the glass fin and the face glass, the top connections. So basically, the face glass, which is the 10 foot wide, 40 foot tall piece, is sitting on a center setting block that has no compression, and then there are setting blocks in the sides that allow for some compression, so this face glass can allow for some movements. The entire system, the face glass as well as the fins, are loaded onto the ground and then captured at the top in channels and shoes. So as we move on, that's a kind of zoom-in plan of the. You can see the glass fin, as well as on the sides face glass pieces, and I'm going to zoom in to more detail even to show this very minimal connection that is basically made up. And here you can see. So we have the glass fin with 4 lights, about 50 millimeters in width. There's a aluminum channel bonded to the face glass. There are 2 gaskets that connect to the 2 face glass pieces, and then you can see the face glass pieces have C channels bonded to each side. And then there are toggle connections that are approximately spaced 30 to 40 centimeters a piece over the entire height of the 40 foot tall that connects the face glass pieces to the glass fin. So that basically makes up the system together with the base condition, the base shoe, and then the top channel. We had to provide some entries into the lobby, obviously. So we have 2 of those entry conditions. And the goal was to make the connections and the joints as minimal as the typical glass joints where you have the glass fin. So we came up with this idea of this stainless steel portal frames, which are about 25 millimeter, so it's I think 1.5 inch by 2.5 inch stainless steel frames that basically transfers the dead load of the glasses that sit atop the 2 entry doors, the revolving doors, and the center vestibule to transfer those loads into the ground. And you can see at the bottom image on the right, the appearance of the entry is very minimal, similar to the typical conditions. We had to deal with a corner condition. Here you can see some details. So basically, again, bonding some profiles, stainless steel plate to one face glass, stainless steel angle to the other, and then they were connected by screw connections. And there's a cover plate creating this very minimal corner condition that almost looks like a glass-to-glass connection. Here you can see some of the kind of early studies of the base conditions. So there's a channel along the perimeter walls that provides fresh air into the building, and that houses basically the base shoe for the glass. All the load goes down, so none of those connections are visible, as well as the top of the system. We had to come up with an efficient way of kind of finishing, installing the glass wall, installing the ceiling, installing some sun shading, and we came up with a system of hanging a piece, prefabricated ceiling piece that can be taken out if maintenance is required. So you can see on the right the finished ceiling condition and then a mock-up of the prefabricated piece that goes into the ceiling. We went through a series of mock-ups. What you can see here is a visual mock-up at Glasbau Thiele plant in Germany, very close to the place where I grew up. And I was very excited when we selected that manufacturer for the class to go there, look at the manufacturing. So you can see we came up with criteria for quality control of those pieces. You see an elevation of the face glass piece there. We identified certain zones that are more important and less important to have quality control. And as we went through the mock-ups and through the manufacturing process of the pieces, we went through the quality control. So for the mock-up, we looked at edge tolerances, edge finishing of the inner layer. We wanted to make sure that the glass fins have no refraction, which you sometimes can see in multiple layers if the tooling of the inner layer isn't correctly done. We were looking for blemishes, chipping, scratches, bubbles, inclusions, hairlines. We were looking at haze of the inner layer, which you sometimes can see. We were looking at bowing of the aluminum profiles that were bonded to the glass fin. Roller wave distortion was kind of mitigated, or we had certain specified range that we would allow for roller wave distortion, etc. So as we went through the initial mock-up, you can see the sheet of on the right side that basically lists all the different pieces, the quality controls they had to go through before they were shipped on site. And on the left side, it actually did happen that we have an inclusion on this mock-up piece that I visited in Germany. So we wanted to make sure that those inclusions were not, that we didn't have them, or if we would have them, that they would be in an area that wouldn't be visible. We went through rigorous testing for the wall. So we had this wall tested in Vinci Labs in the UK. You can see the testing mock-up here that consisted of 3 face glass pieces, 2 fins. And we went through the typical testing procedures. I'm sure you're all familiar with preload, air leakage, water penetration, structural performance, thermal cycling, etc. But what was really exciting is that we did actually do a test for structural redundancy. So we wanted to test what would happen if the glass fin would break in its entirety. So we broke each of the lights of the glass fin individually and tested it with positive and negative wind loads to see what the result would be. And test performed, the system didn't collapse. It basically performed as kind of predicted by the engineering team. Everybody was very excited about this kind of test, destroying a wall to see how far can you go. Here you can see some initial installation. On the left side you can see the glass fins. Special equipment obviously was required to install those large pieces. And on the right side you can see the installation of the face glass pieces. And here's a short video. Everybody was excited at that point. We had spent about a year and a half of kind of design and engineering to really develop this minimal system, and seeing the first face glass piece being installed was incredible. And the speed of installation was unbelievable. Everybody was a little bit nervous. Obviously you can see they're very tight tolerances. It's under the overhang of the building. But here you can see the final image as those guys push the piece in the final position. And here's some images of the final installation, or as you can see the building today, you can go there, experience it. Pretty amazing glass wall. And finally an image from the inside. I haven't talked about the glass enclosure of the rest of the building, but you can see it has kind of this undulating shape that is transferred into the lobby ceiling and then kind of reflected in the lobby wall, the stone wall in the back. So really what we wanted to create was this transparency between indoor-exterior space to really open up the ground floor to the public and to the people of the city. A second aspect of my presentation today was a piece, an artwork piece, a media art sculpture that we installed. On the left side, you can see this is a pass-through that brings you from Canal Street to the park at the west side of the building, as I pointed out in the site plan earlier. And then on the right side, there's an image of the final installation. So we engaged an artist group called Luftwerk Studio, and they've done a lot of work with light, and so we engaged them to come up with an idea for an art piece for 320 South Canal. We had Lauf's Engineering out of Berlin and New York helping with the structural design of the system. Vector Fabricators fabricated the art piece. RGB Lights provided the lighting, the LED lights, and the wiring, as well as the control system for the entire system. And then Goettsch Partners did the overall coordination of the system. You can see an image of the inspiration from the artists looking at tree canopies and how they move in the wind that really drove the design of the system. Here you can see some initial drawings of the system. It was initially 4 clouds that would kind of fly freely under the pathway and kind of guide people into the green space on the west side of the building, as you can see on the site plan at the bottom. Here's a drawing that reflects the final kind of shape and size of the art installation. So you can see in the end it ended up at 2 clouds that were mirrored around a glass bridge that connects the exit stair to the rest of the building. And this drawing kind of just shows a coordination that Goettsch Partners had to go through to integrate the art piece with the rest of the architecture, the ceilings, the mechanical systems, whatever, all the pieces that need to go together. So there's some updated concept renderings of the final installation. And here some structural analysis, initial structural analysis of the system, as I mentioned, done by Lauf's Engineering. I'm not going to dive into too much detail, just wanted to show kind of the process we went through. We came up with a hub design. We have about over 1,000 of those pieces that basically house the LED park, and then wiring connects to the rest, and they connected by these tubes that build up the system or the grid of the sculpture. We built mock-ups. So here you can see initial 3D prints of the hub. You can see a small mock-up to test the initial appearance, lighting conditions, the intensity of the light in Luftwerk Studio. And these are the final fabrication drawings done by vector fabrication at the top. You can see the clouds are broken into smaller segments that are fabricated in their shop and then brought to site. So you can see in different colors the different segments. You can see on the right one of the segments blown up, and then the final structural analyses for the system, how it would perform. Through the process of development of the art sculpture, we finally concluded that the hubs should be casted. So here you can see some of the casting process at Trio Foundry on the west side of Chicago, where we casted more than 1,000 pieces of those hubs. Here you can see the initial assembly of the first segment of one of the clouds, and it was lifted up. We did a lighting test at Vector's fabrication facility. And here you can see the installation. So on the left side, you can see we had to come up with a system where we could basically finish the entirety of the building. We had these pucks, or these nodes coming out of the ceiling. The rest of the building could be finished, the ceiling could be finished, the curtain wall could be installed, everything could be finished, and then Vector and the installer could come back, screw in the extensions, the hangers, and then assemble the entirety of the structure, and everything was pre-wired, etc. Here you can see some finish pictures of the final installation. And here a short video. So Luftwerk came up with a series of different programming for the art piece that is now to be seen every day. And finally, an image from the park. I didn't really go in detail of any other elements of the building, but you can see here, basically being on the west side of the building, looking towards the east, the pass-through. You can see Arboreta, kind of the cloud. That's a pass-through, and the kind of appearance of the park. Thank you very much.
So thank you so much, Joachim. I don't know about you guys. I've walked by that building a million times, and I've admired the facade from afar, and it's incredible to hear that it's 10 feet by 40 feet pieces of glass with those laminated glass fins. It's incredible, and learning about the art installation too is really amazing, so thank you so much. Okay, next up we have Andrew Pries, who is the Technical Sales Director with Boston Valley Terracotta. He will be presenting fabricating terracotta architecture for a sustainable future. I don't know about you, I've always wanted to use a terracotta, and it always gets value engineered on my projects, so I can't wait to hear more about it. Let's give a warm welcome to Andrew Pries.
Hi everyone, thanks for having me here. So I'm here to talk about terracotta. It's a timeless material that has been around since the late 1800s, really, and it's really starting to come back in popularity, and a lot of that has to do with its low embodied carbon, its malleability and durability. The case studies I'm going to walk you through are an interesting subset of the thousands of projects that we've had the honor to work on. They all actually are repurposing and revitalizing historic structures. But first, let's talk about what is terracotta. So terracotta, as I mentioned before, it was known as an innovative material in the 19th century. After the Chicago fire, it was used as a durable, fireproof material for facade cladding that was very easy to produce many, many units from. Stone took a lot longer to carve, and terracotta was a great way to clad facades that way. But what is terracotta itself? Terracotta is made up of a few simple ingredients. Clay, which is mined from the earth. Grog, which is the crushed up, fired ceramic material that is an aggregate and gives the material strength. That's mixed with water, and that can form nearly any shape imaginable: bricks, panels, blocks, you name it. That is then fired at a high temperature, and that is what creates a permanent bond and allows the material to be durable, fireproof, and last for thousands of years with the right maintenance. A couple examples of some historic buildings that we've had the honor of working on in Chicago: 35 East Wacker and 307 North Michigan. Both of these, the restoration campaigns were done not because of the terracotta itself failing, but actually there's water infiltration that got behind to the mild steel that caused it to rust jack, and then the terracotta actually failed. Terracotta, just like most other ceramics, is great in compression, but not so great in tension. Rust caused that. The swelling introduced tension, and we had to do replication. But now the replacement units will again be good for hundreds, if not thousands of years with proper maintenance. But getting back to sustainability, terracotta is really low on the building materials pyramid. As you can see here, really the only other materials that have lower embodied carbon than terracotta is the renewable resources, right? Wood, straw, hemp, those sorts of materials that way. To put this in a different context, Dr. William Carty, who's the professor emeritus and chair at Alfred University in their ceramic engineering program, put together this chart to correlate how much energy it takes to actually produce a ton of the material. So clay, terracotta, that'd be your bricks, roof tiles, require about 2 to 7 gigajoules of energy to produce a ton of material. When you compare that with pretty much any other common building material found on facades, it's extremely less. And there's usually a bad connotation with terracotta. Oh, you fire to a high temperature, that requires a lot of energy, which is true. But it all happens at one place. We're firing it once. If you look at, say, aluminum or some of the other materials, they have to get processed and refined at multiple different areas, and that forces additional energy to go into that stream. So for us, we try to source all of our clay as locally and regionally as possible. We make everything here in the United States. A lot of people actually wonder, why is our facility, our manufacturing facility in Buffalo, New York? It seems like a weird place to make terracotta. It's actually perfectly located for us. We're centrally located between a lot of the major markets. We supply Chicago, New York City, Washington, D.C., Toronto, and it's also very close to our clay pits. So that allows us to provide as many LEED credits as possible for projects or passive house, anything else like that. Another really important part for this, I'm sorry, that's blurry, is the Land Reclamation Act. So we don't want the clay pits, they're open pits, we don't want them to be scars on the earth when they're all done. So when they're done working in that pit, we want to make sure we're working with partners who follow the Land Reclamation Act and restore the pit to beautify it and rejuvenate it, restore it back to a proper ecosystem. It's no longer a scar on the earth. Additionally, we look to incorporate as much recycled content into our clay body as possible. So here you can see a pile of off-cuttings from our production process. We crush this all up and turn it into that grog that I talked about, which is aggregate, and we can add that back into our body, which is about can constitute up to 30% of a formula for us. So this is really important. This grog not only gives us the durability to withstand the freeze-thaw cycles that harsh environments like Chicago, New York City, other Northeast cities would have, but it's also a way to make sure we are upcycling as much as possible. Additionally, we're always doing research to try to find different ingredients we can put into the bodies that are environmentally conscious and sustainable. And to that degree, we have our EPD, HPD, and LEED certifications, so you guys know exactly what we're putting into our body, how much energy is required for production, and everything else that way. The terracotta, you might know it as the quintessential terracotta flower pot color. Well, we actually have 14 different standard through-body colors. We can also work with you to custom develop a bespoke color for your project for a new construction. Also, when we're doing restoration, we can custom match the historic material, or if you want us to match a historically sensitive project next door, and you're trying to play off that, we can match that as well for new construction. And when you look at these images, this is all what's called a smooth texture. We can also introduce textures into the piece too, which add a whole other level of dynamic to the facades. With the way the sunlight hits the textures, the colors can read totally different than what the actual through-body is. It's a really interesting phenomenon. Because it's a natural materiality, there will be a subtle range in color, which I think is actually a great thing. It's not giving you that kind of perfect, pristine manufactured look, but it really warms up a facade. But if through-body is not your forte, glazes is where the possibilities basically open up. We can do anything from a dry, matte glaze all the way up to a high gloss. Any color, pretty much imaginable, including even precious metals, like the carbon carbide building. We recently did some work on that. That is actual gold that is baked onto the terracotta. It's a process called a luster, and that will last for hundreds of years that way as well. With all the finishes, through bodies and glaze, they are impervious to UV degradation. So what it looks like when it comes out of our kiln is what's going to look like 100 years from now, which is a really great aspect of the material. There's also some really unique features you can get with glaze that you really just can't get with any other material out there. The first case I want to walk you through is Medina Temple. You guys might know this is where the Shrine Circus used to be held, and it was built in the 1912 as an ornate auditorium. And then in the early 2000s, Bloomingdale's actually purchased it and renovated it and turned it into one of their showrooms. Now I believe it's a casino. But we had the pleasure of working on this to do some of the restoration work for some of these really ornate panels. The project and restoration, it's always interesting what we find and when we get into this. But a lot of the materials actually was able to stay in place. We're not having to do wholesale restoration for the entire facade. It's more discrete spot replacements that we're working on. And again, the reason why most of those replacements are happening is that water infiltration and penetration, which is then causing the blocks to split. So it's not that the material is actually failing. The material is actually a very good, durable material. It's actually the mild steel is the problem child. This project is unique in that there's multiple different glazes applied to these blocks. We do this all in what's called a single fire application to minimize the amount of embodied carbon going into the project. We could do each color in an additional firing, but that just adds additional embodied carbon that's not necessary for the material or the environment. The next project I want to talk about is one I'm sure you're all familiar with, which is the Willis Tower. Gensler did the repositioning of the podium 2015, I believe, and we had the honor of being a part of this one. So the old podium, if everyone remembers, was a means to basically keep the people in the building and the city out. Times have changed, and welcome people, invite people in. So all 4 entrances were renovated in terracotta flanks, not only the outside of the entrances, but also comes into the interior. Gensler, I think, did a really great job designing this building, and they were really creative with how they went about with their detailing. Oops, I'm sorry, skipped a slide. The white panels are actually comprised of just 2 unique custom profiles that they were able to alternate and rotate to create a really bespoke looking facade, but it was simplicity of parts. So you got a very beautiful facade with just a few components for us. So from a manufacturing standpoint, an installation standpoint is very easy to execute, but create a really dynamic facade. Additionally, we developed a custom die for the bespoke stacked bricks. As you can see, each one of the individual pieces was married to a larger backer panel, so we created faux joints, and then glazed each of the bricks an individual color to, again, create that variegated facade. The reason why Gensler went with terracotta was it's in the loop, tried to pay homage to a lot of the significant buildings that are in the loop, and terracotta is quite prominent here in Chicago, so that's where that came from. And they were able to achieve LEED Platinum for existing structures with this building, so it was really great to be able to be a part of this project. The next project I want to talk about is at Wayne State University. This is the Integrative Bioscience Center. It's found in Midtown Detroit. This is actually an old Cadillac dealership that was built in 1920s and designed by Albert Kahn. Yeah, it looks nothing like that. We provided the solar, the sun shading screen part of it, and this was a really unique project because there are vertical rods that project off the cantilevered element on the roof and tie down into a canopy detail there, but otherwise it's all freestanding. The detailing on this one was really, really interesting. So we had to develop a custom aluminum attachment system that would tie into the vertical rods that held the terracotta in place, and then also figure out a way to cap the extruded end. So typically when you're extruding terracotta, you're going to have these hollow cores that are running through the whole piece of it. The design team didn't want to see the cores that would out for the ends. They wanted to have a clean way to terminate the horizontal bands. So we developed these custom end caps that allow it to cantilever past the vertical structure. So quality control was really important on this project because of the tight tolerances that everything had to fit together and work together. And if the drilling was off or the sizing was a little bit shorter or longer, it would cause the whole system to have problems. So this was a project where we had to make sure, just like any project, that we follow through everything, and I mean, really it turned out beautiful with all the connection details. Just to show a few more of these connection details. And again, you would never know looking at this facade that it was actually an old 1920s Cadillac dealership. It looks like a brand new build. So it's really great to see how buildings can get repurposed. The last thing I want to talk about is our Architectural Ceramics Assemblies Workshop. This is a workshop that we host every year. We're in our 9th year right now, and this is where we invite practitioners from architecture firms and facade engineers to design a bespoke facade that really pushes the envelope of what's possible with ceramic facades and how performative they can be. One of the groups was with Janney Elstner. Majority of them were out of the Chicago office. To design, and they came to us with a proposal to develop a new way to replace cornices. Cornices have historically been stripped off historic buildings because they're very heavy and causing structural issues. They wanted to find a way to be able to put it back both faster, cheaper, and lighter. So we worked with them to take advantage of our rain screen technology, but still pay homage and respect the historic skin of the facade. So what they did is they utilized unistrut systems off the shelf and our off-the-shelf rain screen track and clip system to create a facade that from the exterior looks exactly like a historic cornice, but on the interior it's a much more modernized system that can still attach on the mass masonry walls and be deployed easier in the field. It also gives a lot more adjustment than what some of the historic masonry installation techniques would offer. So here you can see a couple of the team members during the workshop putting together the unistrut to support the cornice. And then Janney actually thought this was such a groundbreaking thing that they wanted to build their own mock-up here at their test facility in Chicago and actually test it and put it through the rigor to make sure that and validate this was a viable project way to proceed in the future. And from all accords, it's a great success, and they're now looking for the right project to be able to deploy this on. So just to give you a little context, this is a historic building on University of Buffalo South Campus, and that's kind of where we're pulling the profiles from. So you can see the old versus the new. Unfortunately, the old wasn't terracotta, but that is everything. Thank you, everyone, for.
I'll scream. Thank you, Andrew. I hope you guys enjoyed that. I think it was amazing to learn about the Medina Temple, the Willis Tower repositioning. The terracotta there is just gorgeous if you've been in the lobby and learning more about terracotta from a sustainability perspective. So next up we have Anthony Cinnamon, Associate Principal with Weiss, Janney, Elstner Associates Incorporated. He'll be presenting the MIT Schwarzman College of Computing, which is absolutely gorgeous, and I think you'll really enjoy it. So everyone give a warm welcome to Anthony.
Thank you. Really appreciate the opportunity to be here. Also really appreciate all the friendly faces in the audience. Hopefully it'll cut down on the heckling a little bit. So we're going to talk about the Schwarzman College of Computing. It's a new construction project. It's on the campus of MIT. So if you're not familiar, MIT's outside in Cambridge, outside of Boston, here on the Charles River. Fun fact is that the project actually already shows up on Google Maps. It was recently completed, but so this is actually what you can see during a shot during construction from Google Maps, kind of fun. And also, if you're familiar with MIT's campus at all, it's almost directly across the street from the Frank Gehry Stata Center as well. So it gives you just a little context about where it's at and how it's performing. Fun fact, if you want to get your name on a building, if your name's Schwarzman or something else, you donate the entire construction budget to the university. So just fun fact, if you're looking to get your name on a building somewhere. The project team consisted, SOM out of New York was the architect of record. They were the designer. The general contractor was Suffolk, based in Boston. Our glazing subcontractor was Gartner Permis de Lisa. We'll talk a little bit more about them as we go. We were fortunate enough to be brought on by MIT as their enclosure consultant for the project. So as we all know, projects don't get done without a great team, and so we were certainly fortunate to work with some of the best people in the industry here on the project. So the design is, in and of itself, fairly simple. It's a rectangular building. It's all unitized curtain wall. About 10 stories. The interesting and the thing we're going to be talking about most today, interesting part, really is this main facade here on the street facade, which is a closed cavity unitized facade. We'll get into a little bit of the details about what that means, how it works, and how the design was approached. The remainder of the building is, I'll call it standard unitized curtain wall, triple glazed. We'll leave that for another day. So for those of you who aren't familiar, just very quickly, one slide here to give you reference on what a unitized curtain wall is. It's basically a panelized system. The panels are fabricated off-site at a shop, brought out to site, and then installed as a panel system. So we're going to see that this closed cavity facade system has also been unitized, which is for us, in thinking about it, was kind of part of the challenge. We'll see later on that, this is something that the folks at Gartner Perma-Stelisa do in their sleep. So it was kind of funny to ask them all kinds of questions and have them look at us like, oh, what's the big deal? We do this all the time, right? So what is a closed cavity facade? Well, a lot of us are familiar with a double skin facade, and it's similar in that you basically sort of have two layers of glass. You have an outboard and an inner layer of glass. In a double skin facade, that cavity between glass is typically ventilated somehow, and whether that's done automatically or manually, something like that. A closed cavity facade, this is really it's not ventilated. It's meant to be not completely sealed, but mostly sealed. And the way that that's accomplished is that there's a constant supply of clean, dry air that is supplied into that cavity. So you can see in the graphic on the right, the green arrow basically is where the air comes in. Now, if you're thinking to yourself, okay, well, let's see, if I've got air coming in, I'm just going to blow this thing up like a balloon until it pops, right? So at the bottom where the orange arrow is, there are very, very small venting ports down there to allow at least some of that air to get out. The main issue, obviously, the main thing for providing that air in this cavity is to prevent or reduce condensation. And then again, the funny thing is, there aren't very many closed cavity facades here in the United States. Of course, they're fairly ubiquitous over in Europe and especially in Switzerland and other places. So again, we were throughout this whole design process very concerned with, what happens if dust gets in there? What happens if condensation gets in there? What happens? What happens? What are we going to do? And the folks from Gartner are like, you go to the inner light, you lift it up, you wipe it out, and Bob's your uncle. Like, okay, easy for you to say, but it's just not something we're used to. So the location of the closed cavity facade here, like I said, is on the street facade, and this one is made up, and this is the typical panel makeup. So there is a vision area here. There is also an opaque area above that. And that basically hides the ports where the air is being brought in. It also hides the roller shade pocket that's up in there. There are automatic roller shades that are in that cavity. We spent hours and hours talking about those shades because, obviously, as you can well imagine, they're not very accessible. But it's all part of one unitized panel. Another interesting point on this project is at the very edges we had these what we called flyby panels too, which are not a closed cavity facade, but unfortunately, as you can see, they do provide some potential thermal bridging into the main part of the facade, which we'll have a look at quickly. So this is basically a section of our panel, and so you can see that the outer light is actually on a diagonal. It's actually sloped, and you can see the overlap at the bottom. So all of these panels sort of end up in kind of a shingle pattern, as we'll see once we get into construction. The outer light is a laminated light. The inner light, in some of the original shots and in some of the original drawings here, was actually a laminated IG unit. As the project progressed, that actually became a triple glazed unit on the interior there. So you can see that some of the interesting points here is that this is where the air is brought in. Basically, this is where the air is pumped into the cavity, and then in this particular case, and it's tough to see in these drawings, but that is where the venting happens. So you're still venting sort of out into that, into the exterior there, but with that constant production of air, that's going to prevent any air from coming back up into the cavity. So just a few plan views, and you can see part of the challenge here with that sloped outboard light is that some of the framing gets pretty deep once you get out to the base of those panels. But the nice part about that is it really provides a very robust system. As you'll see, we did some mock-up testing on this, and it's almost, I'll knock on wood, almost impossible to get this to leak because you've got so much room there, so many layers that you have, and so many gaskets and that you have to get through in order to get to the inside. But you can see, in and of itself, it's a fairly standard sort of unitized panel. Now, why do we do this? Yeah, it looks cool and it sounds cool, but why are we really doing it? Well, so they're doing it for thermal performance. Again, this is done a lot in Europe, where the codes are even more stringent than what we have, where you need to get down to that thermal performance in order to meet code. So as part of the project, they were doing lots of thermal studies on these panels. So we were getting, center of glass U values of about 0.1 and a U factor for the overall unit of about 0.14. So you can see that the energy-wise, it's very efficient. Obviously, there's a lot of detailing that goes into it to make sure that it's constructed correctly. As I mentioned, the project has these flybys on the ends and on the bottom. And so one of the things we were worried about was thermal bridging, basically because there's a lot of structure there. There's a lot of thermal bridging through that structure. So we did some more thermal analysis. We didn't do, the Gartner did, of those flybys, and really spent a lot of time on the detailing of that to prove that the thermal plane was still, this is basically where the flyby would go, and just basically proving that we weren't getting, we're getting a little bit here, but for the most part, the thermal bridging was being taken care of by some insulation and some other thermal breaks that were in that flyby structure. So we went through a whole design assist process, and it got to a point where, obviously on something like this, something complicated like this, we have to do a performance mock-up. Because of the sort of sensitive nature, as you can imagine, of these units, the decision was made to do the mock-up at Gartner's facility in Gundelfingen, in Germany. So they constructed they have a full, they have full testing capability there. If you've ever seen it, it's pretty impressive for a fabricator. But so Gundelfingen is about an hour or so outside of Munich. Gartner has a massive facility there. It's a very well run, and if you ever do get to go there, make sure they take you through their mock-up shop, where they have mock-ups of all the projects they've done. It's really interesting. But this was our mock-up, and unfortunately I wasn't able to get a shot of it before the spray rack was up there, but you could start to get the scale of the size of these panels. So really it's just 2 panels tall by 2 panels wide. We did want to mock up that flyby a lot for structural reasons, obviously, as well. And we did run this through the gambit of air, water, structural, thermal. We did movement on it. And so one of the tests we ran was a dynamic test, and if you've never seen a dynamic test, it's sort of the propeller test, right? And so we actually set up 2 propellers. We did them separately. This one we did separately just to sort of test those flybys, to make sure that particular joint was watertight, but also we were just sort of interested to see what it was going to do, sort of under a dynamic load like that. And it was kind of fun to watch it because those flybys, really start flopping around a little bit. So it was kind of fun to watch, but. So as I mentioned, the system itself is very robust. So like I said, we ran it through the gambit of tests. No leaks, no failures. Everything performed. That's not something you get in a performance mock-ups a lot. Is that everything sort of passes on the first try and sort of sails through. So if you've ever been a mock-up at Gartner or in Germany, this is what you do when you pass the mock-up, right? So at 9 o'clock in the morning, you drink beer and eat sausage and have pretzels. It was non-alcoholic beer because it was 9 in the morning, so I will preface that. But it is kind of a fun tradition that they do there, which is kind of nice. So We did get a chance to, talk with them a little bit more while we were there for the mock-up about some of their production and those kinds of things. And on the left-hand side, they were even doing some of their own sort of just in-house thermal testing on the units, just to kind of see what kind of data they were getting back, not part of the project. One thing that's interesting that they do for all of these closed cavity facade projects is that they do before it basically gets shipped out to the job, they do an air exfiltration test on that unit just to make sure that that they're not getting a lot of air exfiltration. So that's what the top right is. They don't allow any photographs, so I couldn't get a picture of the fabrication on the line. But really important, obviously, that these units are sealed up as much as possible, excluding the vents. One interesting part about these units as well is that how do you transport them? Typically, what they've been doing is that they load a bunch of these panels basically into a container. They have a compressor in the container. They basically hook up the air to all of these panels so that there's already that constant flow of air in there. So they're at least trying to reduce as much condensation there as possible. What they actually did for our project, which actually worked out really well, and it was their first time doing it, and they had done a bunch of testing on it, is they basically vacuum sealed these in foil bags so that there was no air coming in, no air going out, obviously, and it actually worked out really well. This is an example of something they were doing on their own just to test. They basically vacuum sealed this, had it sit outside for 4 months, had some thermocouples in there, were testing humidity in there just to make sure we knew it would work before it gets to the job site. So so we passed the mock-up, gotten into production, so now into construction. So you can see in this photograph, some of the flybys along that lower row and up the side are in. The flybys were field glazed, so this is all structurally glazed. The flybys were field glazed, and so in order to, you can see, how many unitized closed cavity panels we've got there. You've got to have a pretty decent compressor to run all these. So all of the air that's being provided is basically coming from this compressor, which is in this bunker up on top of the roof. There's a couple of places, there that room is vented, but that's something that's obviously, that compressor is pretty important to the system, so it's got to be weatherproof, weather tight, and also, from a structural standpoint, has got to be able to withstand all of the loads that the building's going to see. So this was actually, from a scheduling standpoint, something really important. They actually sort of built this bunker first, got that compressor in so that they could start hooking up these panels once they got there. So there's a few shots of these being installed. So they were loaded up on the roof, picked from the roof, and then dropped down over the side. You can kind of see the scale of these, and in the middle picture here, you can also start to see some of some of that shingling there on the sides too. You can see that there's some frit. There's a frit here over the structural silicone to kind of hide that. But you can see how they kind of lap over each other. And then on the right, that's actually the actual first panel that went in. So again, just to kind of give you a scale of what this looks like, this is one of the flyby panels here. One thing I didn't mention, which you can kind of see in this photograph, is that there is a bird frit on all of this as well, which was on on the inboard side of the laminated layer. But you can get a feel for the scale of these units, and what a challenge it is to get these set. So once they're set, they immediately want to get these hooked up to the air. So you can see here on the left-hand side, this is actually the hose. This is actually the air hose that's going directly into the unit, and then this conduit basically is what's feeding the air, and so that hose then is just basically getting hooked up to those ports, and air is already started. So, like I said, they said that that inner light is not structurally glazed. It's a dry glaze, so it's a gasket system. So again, the folks from Gartner were saying, you just pull the gaskets, and there's a deep pocket up at the top, and you can just get some cups on it and lift up that huge triple pane light with a couple of guys. The folks from MIT are not interested in doing that. They said, hey, we don't care if dust or dirt gets in there. We're not going to bother with it. So, but this, so you can see here, this is after the first couple of units have gone in, and just like any other unitized system, once they go in, they just, it's the same thing about another 1,000 times. So you can see it starting to come together there. So this is it with that entire closed cavity facade, and basically all the facades complete. This was completed, I want to say, at least the enclosure was complete maybe summer or fall of last year. And then this is my last slide, and I just like to have this slide here because there's a lot of times when you look at the beginning of a project and you see a rendering and you think, wow, that's really going to be fantastic. And sometimes once you get to the end of the project, that rendering doesn't quite look like what it did at the end. This one I think was pretty faithful, and it was, they were able to capture a lot of all those basic design elements and really keep them as part of the project. So thank you, and appreciate your time.
Thank you, Anthony. That was incredible. I personally loved learning more about closed cavity unitized facades. I don't know about you. And I also really like the idea about drinking beer at 9 a.m. with some sausage and pretzels, so maybe we all should get together and do that later. Anyway, next up in our final presentation for the morning session is Dean White. He's the Regional Facade Sales Manager for Cosentino. He will be presenting sustainable facade design with ultra-compact stone, another kind of carbon-neutral solution. So please welcome Dean.
Thanks for having us in Chicago. I'm going to run through and talk to you about Cosentino, give you a quick overview, our approach to sustainable manufacturing and bringing sustainable products to market. Decked in ultra-compact stone, which is our material we use on interior and exterior buildings because of its unique physical properties. We'll talk about how you can get on the wall and ventilated facade attachment, different methods, and also how it can be quite easily integrated into curtain wall. And we'll look at a couple case studies. So to begin with, Cosentino is a company that is in the south of Spain. It was started in the late 1940s by a couple Italian brothers that moved from Italy to the south of Spain and started a marble business. We're still in the marble business to this day. We're one of the largest exporters of natural stone on the planet. And in the 80s and brought to market in the 90s, silestone quartz countertops. So that's where we're coming from. Jump forward into the 2000s, we brought to market in 2012 decked in ultra-compact stone, which was referred to as an ultra-compact surface at that time. And we'll talk about that in a little more detail. We're in 150 different countries, 6,000 plus employees. I've been with the company 3 years now, and we had 4,800 employees when I joined. We've gone through a lot of growth, a lot of added production capacity and new products coming to market, which is really key. Decked in, we have 3 production lines in the south of Spain in Almeria, and I'll talk about those in a bit more detail. And that gives us about, on that ultra-compact material, about 250,000 square feet a day of production capacity, servicing interior applications and facades and exterior applications. From a sustainability approach, we use the 3 pillars of environmental, social, and governance, or rather transparency might be a better word for that. So I'll come back to the environmental part in a minute, but the social means that we want to have a lasting, sustainable, positive impact in the communities we're in. So for instance, where the brothers moved in the south of Spain, it's actually a little town called Cantoria. We're still in that. We're the largest employer in the region, one of the largest companies in Spain, and we give back to the community on a regular basis. Not only that community, but in other communities around the globe that we're in, we always work towards sustainable efforts like cleaning the ocean and things like this. The governance side just says that we're transparent about all the efforts around sustainability. So we have third-party validation and all our sustainability efforts, and we regularly report on them. When it comes to the environmental side, this is the more physical part of sustainability, and we follow the philosophy that we're working in a circular economy. So not like old-time manufacturing where you produce something to go out and get consumed. We're talking about a circular economy that we're participating in and we're trying to move forward. So one of the things, you know, if you talked to us 25 years ago, we weren't necessarily looking at making sustainable procurement. So the vendors that we work for some raw materials, we are going to partner with one that's sustainable over one that isn't sustainable. If it is a really good, you know, even if there's a delta in the price, essentially. So that's one approach. So the procurement side of it. The second part is designing the products from the beginning to be sustainable. You know, in the past, those would have been an afterthought, but now it's from the very beginning. How much energy is it going to take? How are we going to transport it? What are the different ingredients, the suppliers, all that stuff, so that when we develop the product, we know that it's going to be sustainable right from the start. We design it that way. On the production side, we look to use best available technologies. So I'll go just a little bit more detail on how this material is made, but the final stage, they go through 200-meter long ovens. So we have 3 production lines. We have 3 of these oven stations where the product is fired and the final sinterization. That is run off natural gas. So currently we offset our emissions with carbon credits and projects around the globe that we invest in. We are switching that to hydrogen. So our emissions are going to come way down when we switch those furnaces to hydrogen. So that's one thing we're doing. The other thing is, and you'll see in the next slide how big our campus is, all the electricity we use is renewable. We have the largest self-consuming solar farm in Europe. That only provides us with about 15% of the power we use. We use the equivalent of about 400,000 homes. All the other electricity we use comes from a certified renewable source of wind or solar as well. Water efficiency is really, really key. We're in the south of Spain where all those old Clint Eastwood spaghetti westerns were filmed, and water's like gold. So we bring water in our system. We use a lot of water in the system to mix the product before it goes through its production process, and we recycle 99% of that. Some we lose through evaporation or for feeding a green belt that we have around the facility. So much water that we don't discharge any water, so once it comes in and captured, we keep recycling it until it is used up. And then we also built a treatment plant to recycle the water from the communities around us. So very, very key on the water side and the conservation of the water. And the waste management. So we have a zero waste philosophy around our production. So what we have fall off during production, we work to recycle it back into new material. And that recycling is not 100% at this point for what falls off, so we stockpile what we can have, can't use right now, and our R&D department is constantly working on how to reintegrate it, because the goal is to get back into whatever comes into the facility doesn't leave. It gets put into finished product at some point or some other use. Logistics is a big part of what we do. Like I said, we're in a lot of different countries, but logistics at the production level, at the production facilities, is really key. So we move a lot of material around, a lot of slabs everywhere, and we move them with robots because they're much more efficient than human drivers. I know if you're like me and you get behind a wheel, you start looking around, sightseeing, your buddy's 100 feet over there, you stop over, have a quick chat, and meanwhile you got a load on and you're trying to get to the warehouse. The robots don't have any friends, they're just moving around, getting their job done. So that really reduces emissions. The product itself has a very long life cycle and very low maintenance. So it has a low total life cycle cost and a limited impact from that side of energy that goes into maintaining it, or chemicals, or that type of thing that some people need to clean their material over years. You don't have to do that with ultra compact stone. And then of course the end of life recycling. So it is a totally recyclable product, and it can be brought back to the factory. What that means is, and no, not the next one. Let's just go back one here. I'm going the wrong. How do I go back with this? There we go. The material itself is carbon neutral from cradle to grave. So we calculate right from the manufacturing to delivery to the job site anywhere in the world, and coming back on the recycled side, and it's carbon neutral. The only material in its class that's carbon neutral. So what is it? It is a material where we mine 20 plus different minerals out of the earth. Minerals have gone through the metamorphic process for millions of years. We pulverize them down, we mix them in new recipes, make new colors and patterns and so forth, and we keep some humidity in that material and form a slab out of it. So it's a slab material, it's not an extruded material. So by inference from a design aspect, that means it's a flat material, it doesn't have profile, it doesn't have curves and so forth, it's a slab. And then this slab gets formed and it goes down the production line, and the first major station it hits is a 25,000 ton press. Presses it for 10 seconds, it makes it ultra compact. So that's where the terminology in the industry comes from. That ultra compact makes a very dense product with unique physical properties. Then it goes and hits 3 different decorating stations where we drop mineral pigments on it, make patterns and colors, and then the final stage of those 200-meter long ovens. And in those ovens, it heats up to just about 2,300 degrees Fahrenheit to a liquid state, and then when it cools, it's all bonded at the molecular level. And that really passes on some really unique physical properties that we'll talk about. So it's UV stable. As the terracotta glazing was talking about, this is a product that is fired at the end as well and melted down and cools, and that is UV stable. It's going to look the same 50, 60 years down the road, 100 years down the road. It's not to degrade over time. It's non-combustible, okay? Very important, obviously, for our industry. It's non-porous because of that ultra-compact, that compaction, and also the fact that it gets fired. That non-porosity means that it's graffiti and stain-proof. So if there's graffiti or stain on it, you can clean it off with chemicals, you can clean it off with soap and water. It'll come off the next day or 10 years down the road because it's so non-porous, those agents won't bite into it, okay? Has a very low coefficient of thermal expansion. It's freeze-thaw proof, so it can cycle through freeze-thaw cycles with no impact because it has very low water absorption for one. Large format we'll talk about in a minute. Very consistent in its dimensions. So it's a highly automated production process, very few people in the factory. And this material is the same gauge from slab edge to slab edge, which is and the same density all the way through it. Durable, it's 7 on the Mohs scale, so it's diamonds, topaz, or itself that's going to scratch it. You know, metal's not going to do anything to it. We take chainsaw to it. There's sparks flying everywhere. It looks like it's all marked off. You just wipe it off with a cloth. Looks just like new. So it's easy to clean and maintain and very low maintenance costs over time. And I talked about the low life cycle costs, carbon neutrality, and it's got a 25-year material and finish warranty. The formats, so up until October of 2022, we had 2 production lines that did a 56 by 126 inch slab. And we would do that in different thicknesses from 4 millimeter, 8, 12, and 20 millimeter. 12 is ½ inch, for instance, quarter inch with the 4 mil. And that material, it doesn't matter what the thickness is, that was the max slab size that we could work with, or max panel size we could do. In October of 22, we opened a 3rd production line that does a 64 by 130 inch. That was really key for me in the facade side because now we got past that 5-foot module width that often gets used in unitized construction. So very, very key. We have 70 plus standard colors, at least that in special orders or things we've done in the past, available from stones to marbles to solid colors and wood type colors. Anywhere from actually 20% now, and there's a couple that are 100% recycled content now. Custom colors, this is something we excel at. So we do not only excel at making the custom colors, we do it for less minimum square footage than many other people in the industry. So if we're doing a custom right from scratch, we can do it for a 25,000 square foot minimum. If we're taking a color we've done before and a texture, and we're bringing things together, we're modifying something we've done, or we're bringing together a new combination, then that's a 10 to 15,000 square foot minimum, which really helps, especially on the large facade and curtain wall projects. What you're looking at here is a job in Seattle that hasn't started yet. Was initially designed with a different material than ours, with a terracotta color, and the curtain wall contractor came to us and said, we want to use Decton on this job. So we had a terracotta color. We said, here it is. They said, yeah, but that's a matte finish. We will need some texture, so we added texture to it. And now, it's a 95,000 square foot job or something. Once that job starts, we're in a leading position now. I want to point out something about line number 3. So line number 3, that larger panel size, this was in 2021 when we started this. I knew that production size was coming later in 2022, and this job still hadn't started. We had 49% waste with our standard size, the 56 by 126, and we moved that to 25% by using the larger size, and we can now do custom slab sizes off there, and we got the waste down to 10%. We do a bunch of solid colors that helps us compete against other material classes. We do design assist, which is really key, so we get involved earlier, how to bring costs up, but also how to meet, the design intent. We provide full, depending on who our customer is, full slabs to them. We provide it cut to size, often for curtain wall contractors, it's cut to size. We can provide it cut to size with holes in it or grooves, depending on the attachment method. Lead time is 10 to 12 weeks. We always put a fiberglass mesh on the back of it for fall protection, so if it gets hit, nothing falls on anybody's heads. I want to just talk about line 3 a little bit more. It doubled our capacity for one. It's more flexible, so that press that has a plate on it, that's how we put texture in. We can create and make changeovers on the plate on the press easier, so we can do custom textures as well. Those non-custom slab sizes are really key. It's not a wide open field, the Wild West, but we have widths and lengths that we can put together in different combinations and bring that waste down. I had another job, had 38% waste, went down to 10% when we found a custom size. And we're now, in this material, it's typically not through body, but now we can do through body with this product. So some of the new colors are through body. And you see 4 and 5 there. We've got the machinery now. We just purchased machinery for a 4th production line, and we announced in October, and it's out for tender now. I'm not sure if it's awarded yet. We're building a factory in Jacksonville, Florida, that is a decked in production line. Facades, rain screen, ventilated rain screen, curtain wall, direct adhered. We have a lot of different attachment methods for ventilated rain screen, from mechanical, hidden mechanical, to visible mechanical, to hidden chemical, structural adhesives, pressure equalized systems, open joint systems. There's a lot of different ways to get on the wall that hit different budget points. Curtain wall integrations is quite easy. We worked with Luma Design, who some people here might know, to get a standard set of details, which we know nobody will ever use because they have their own, but we just wanted to visually show how easy it is to integrate in a captured system or an SSG system, and how easy it is to unitize. So this case study here is Cap West in Munich, Germany. Weil Eritz was the architect, and they actually used hidden undercut anchors to install the decked in panels on their wall units. So you can see their wall unit left. They sent us their clips in Spain. We put them on, and then they hung them on their wall units, stacked them on site. You can see at the bottom there's no panels there. That's because they were waiting for the final dimensions down at grade, so they knew what size panels to order. Here's another case study here, Toha in Tel Aviv. Really unique product, a really unique project by Ron Arad, where you've got the mechanical of the building is down on the bottom. The top is a restaurant, the rest is offices, and you'll see this a bit clearer here. So you see on the second picture from the right, all those panels are installed in an X-type shape to provide ventilation to the mechanical area of the building. Okay, so that's pretty unique. On here we've got 300,000 square feet of decked in on all the hard surface that you see, and 11 different colors, 6 of them were custom. Here's a job here in Chicago, one of the jobs in Chicago where you've got some book match and end match. So this is at 44 North Orleans, and Von Weiss Associates was the architect, installed by a sister company of ours called Stone Systems. They used a combination of a mechanical and a chemical attachment for this one. And in particular, they used a marble color where they did some book matching, end matching. And I'm just going to finish with this final slide where decked in is a very unique product. I call it unique and universal because everywhere you have a hard surface, you can use it. So that's interiors, countertops, floors, walls, pedestal decks on the exterior, pools, outdoor kitchens. Everywhere there's a hard surface, you can use it. And Rafa Nadal is one of our spokespeople. We did a custom blue for him because he has a custom blue. And everywhere you look, there's a hard surface. It's Cosentino material, mostly decked in. Please stop by the booth, the table there, and ask any questions you have. We have local people. I forgot to mention that. In North America, we have 300 salespeople, 80 to 90 people that are doing A&D sales and working with customers on the commercial projects. And here in Chicago, we have a showroom, and we also have a center that has a showroom and a warehouse. And we're in 60 different locations across North America, so we have a big footprint. Thank you so much for your time.
Thank you so much, Dean. It was really interesting to learn more about ultra-compact stone being a carbon-neutral facade option. I really enjoyed it. I hope you did too. And while that's happening, we'll take a break, a networking break now for about 40 minutes. So everyone stand up, shake out the cobwebs, stretch, whatever you need to do, head upstairs, engage with each other, our exhibitors, and then be back in about 40 minutes. Thank you.
A single room enclosure. This is a few years ago, pre-pandemic. where we were 3D printing this enclosure. It was a collaboration with Oak Ridge National Laboratories down in Tennessee, as well as the University of Tennessee in Knoxville. They had the printer, think of a parking space, that was the size of this 3D printer, and they wanted to know what can we do with this, how do we build it, and talked with us, with our architects and engineers, and we threw a lot of things around about what we could do with this. And the intent with this was not to show off the technology, not just to show off the technology, but to also understand different elements that can go into this building. So we did come up with this structure here, and the intent there is that, you know, it works well in the X and Y dimension 3D printers do, but how do you build this up? How do you build and put together the prints to create an enclosure at this point? So we came up with this arrangement with these C shapes that then would come and create a circular element to it that then we would stack together to create Amy. And you know, one of the advantages of 3D printing and additive is that's what it is. There's no waste. You know, you take a 2x4 to build something, you cut pieces out of it, throw the waste away. Concrete, you form it up, you discard the forms at the end of the day. Steel, you're not maximizing the use of that steel section that's utilized to its full extent, but with additive manufacturing, you put the material where we want. So we did a lot of studies of where the material wants to be, where the loads are, and that's what we printed as a result of it. And so the enclosure is the structure, and the structure is in the enclosure. But for the purposes of this presentation, it was another element, another technology that we utilized, which was called modified atmospheric insulation, MAI. And the intent there, it's part of the refrigeration industry. It is a vacuum sealed insulation material in foil that, you know, you read up here, 1 inch of thickness of that MAI, you get an R value of 32, as opposed to, you know, typical residential construction, 6 inches of bat, you get, you know, a third of that. So that was very attractive to us in a small enclosure in this demonstration piece that we did. It was also malleable, it could be curved to fit the forms here. So again, figuring out where we wanted to put opacity for structure, for enclosure, and make it perform. These are some of the details that we utilized. We integrated a lot of functions into this, whether it's the MAI, which had to be encapsulated. That was one of the cons of the material. If it gets punctured out, you know, it's useless at that point. So again, we made sure to 3D print both the outer and the inner shell to this to encapsulate it, as well as incorporate a lot of other details to the facility. So that's one premise of, you know, the additive manufacturing, but heavily insulating part of the project. The other premise is the use of an offset core. And, you know, I mentioned inland steel before, back in the 50s, the idea of, you know, we're used to doing towers, central core towers. The core is in there. It's also part of the structural, the lateral system, all the dark functions of a building, the elevators, the restrooms, mechanical spaces, service spaces, all tucked into that core. And then you have your lease spans and your residential space or your workplace all around that. Some sites, some projects, the idea is to use this offset core like we did with inland steel. Again, all those dark functions, hold on. Yeah, all those dark functions are in the core here, allowing for this free space. And I know a lot of you architects here occupy the inland steel building. You know, you are on one floor. You have access to daylight on all 4 facades. You see everyone you're working with. And, you know, there's an intent and purpose behind it. Inland steel is a 60-foot span. You'll see a lot of that in my presentation moving forward. Worked on Broadgate in London similarly. While we're not totally detaching the core, this was a purpose because it was a very small floor plate. In Broadgate, this site particular had a view corridor to St. Paul's Cathedral, so we really had only half the site, or maybe even a third of the site, that we could put a tower on, which we did. Also, there was rail lines going beneath it, so where we could actually put structure. That's why you see some of the bracing as it comes out. It was a very complicated site. So part of the solution on this very small floor plate, and if you could read the numbers, it's 18 meters, again 60 feet, but was to incorporate this offset core into the building and into the facade. Mount Street. Quick side note, Tony presented on our MIT building the closed cavity facade. We also did a closed cavity facade on this project in Sydney, working with Permis de Lisa and Gartner and company there. But, again, it's another offset core building. It is in North Sydney. You have these great views on 3 of the facades back to Sydney. And then due to some of the adjacencies, we tucked that core on the west in this case. Between the columns, 60 feet, we cantilevered some other space to make a wider footprint to fit out the site. You can also see us introducing bracing into this project on the external side. Part of the issues with the offset cores, you no longer have that central core for lateral bracing. We have to use other methods to efficiently brace the project. On a mega scale, worked on a project in Guangzhou Chamber of Commerce where we're using an offset core. You can begin to see bracing on the perimeter of the building. And then coming back home, project we recently completed a design on Ritz-Carlton in Nashville. Both of those towers, the hotel and condominiums, as well as the adjacent tower for multifamily, all utilize a small offset core on the perimeter, as well as what we're doing currently in Miami and is on the boards, taking advantage of the views in a small site. Now, why the offset core? When I was looking at a few of our projects and looking at their performance characteristics, 2 stood out, and that's going to be the premise of the case study the rest of the way here. Our University of Illinois engineering building and our 800 West Fulton project. And you'll see some of those similar characteristics with offset core, heavy opacity, limiting the window-wall ratio as means and how we got these buildings to perform the way they did as part of our portfolio. And here they are, 800 West Fulton, locally here in Chicago, and the University of Illinois downstate in Champaign, campus instructional facility. You can see the reduction numbers on energy as well as their energy usage. And I'll talk more about that and how we got there. So 800 West Fulton, for those of you that don't know Chicago, you have to the east, you have the lake, you have the Chicago Loop, separated by the Chicago River. Then we have the West Loop, the Expressway, and then we have Fulton Market, which was traditionally a meatpacking and warehouse district, but has come over the past 20 years as a destination, which was initially for food and beverage and hospitality, but now for workplace and for living. Our site is right there on the east, really at the beginning of the area. The Fulton Market sign is right adjacent to our building. But you can begin to see three-dimensionally there's a lot of different project types and heights there. Again, the old industrial and warehouse buildings and the low-rise, but then also high-rises, large projects being formed in the area. And I guarantee that's out of date. For those of you that know Fulton Market, a lot of other buildings have come in. So it's with that massing, the massings that we see that shape the tower itself, the street level urbanism, the podium, mimicking a lot of the warehouse heights and massings that we see there, and then we put a tower incorporated into that to take advantage of the FAR and what we could achieve on that site. We did set it back to maintain that street line. And the added move of the terraces to help navigate what was about I got a slide here, a 300-foot height adjacent to us down to what we see with the warehouses. It was a good transitional building from the various massings there. And we incorporated an offset core into this building. We have that higher building next to us at 330 North Green. That's where we put our core and then allowed for the views back to the city as well as to the rest of the Fulton Market area, including those step terraces. So as a result of this, the step terraces and the offset core, we had a variety of floor plans. And this building was designed pre-pandemic, constructed during the pandemic, and then leased out and occupied post-pandemic. And this variety of floor plates, it's an office space. We know what's happening with workplace now. There's not a lot of need for it. But this variety allowed for various tenants to come in, and they found that to be attractive. And so, the high-rise floor, if you needed 20,000 square feet, we had those. Low-rise all the way down to 35,000 square feet, and you can mix and match as you needed. You can begin to see those step terraces angled with opposite every 2 floors. All the meanwhile, we have that same consistent core, which was to the north of the building in this case. And here's an aerial where those terraces are. Again, this building became very popular coming out of the pandemic because everyone wanted access to the outdoors for workplace, and this building succeeded in providing that to the tenants. I mentioned window wall ratio as a way to achieve that opacity and performance. While this may seem like a glassy building, there's actually a lot of opacity into it, 54% window wall ratio. And it's strategic. Again, we have the use of the offset core, so we're able to put a lot of those functions on the north facade, providing that opacity. With the use of this technique, it made for an innovative and integrated structural solution. Again, 60 feet, right? Column-free. Long span is the main structure, the main mass of the building. Where those terraces are, we have a 15-foot cantilever off the structure that steps its way back. And then the core is actually cantilevered. Again, it wasn't doing the structural, it wasn't the structural that we needed at this point because we had the lateral bracing, we had the main structure, and so we actually cantilevered the core pieces off of that, and we found this to be the most efficient system for the project. Here you can see it on one of the unleased floors, again with that 60 feet, the core to the right, as well as those cantilevers that then again would step back as you move through the massing of the building. I mentioned the core, we are still strategic in where we are able to put glass and daylighting. It wasn't just one blank facade over there. We found, say in the middle picture here, that the egress stairs could actually be the communicating stairs for the tenants, right? With just a little upgrade in the finishes, that use of putting daylight into the facade there and graphics. There aren't tenant stairs. We didn't have knockout slabs for tenants to come and put in it because they could utilize the egress stairs for dual purpose and promote the use of vertical circulation. The toilet rooms. We had glass there. Obviously, we had some translucency to it for viewing purposes, but natural light is able to come into those common areas in the toilet rooms. And the elevators themselves. While you are waiting for an elevator, you have a view out. The elevators, the cabs, those on the perimeter are actually glass, so you can see on your trip up and down, whether to amenities, to your floor plate, to the building lobby. You have views to the outside and natural daylight as part of that process. So being strategic, and we're able to put glazing and opacity. All the floor plates have access to the outside, every 2 floors have access to the outside. All of them have access to natural daylight. And even the tenant amenities, whether it be on the ground floor or more importantly at the top of the building, have access to the outside and daylight. And these terraces are right-sized, appropriately scaled outdoor spaces for the tenants to enjoy and have those great views back to the skyline. It's always nice to do a project outside the city because then you get the views of the skyline, which is purely wonderful in Chicago. I need to talk about brick. You'll see brick in both projects. There is a historic character to the neighborhood of Fulton Market with the use of brick, and we knew we would incorporate that material into our facades. We did a lot of study on the typical Fulton Market facades. Again, a use of a lot of steel on the lower grounds, but definitely brick. We investigated the colors there. We started comparing different blends of bricks, and I know there's a presentation and panel later on about the use of brick, which is just a fabulous material. And in this case, we used a precast brick, brick inset into precast as one of our solutions because of the high-rise nature of this project and the scale of this project. Not only did we do visual mock-ups, we did performance mock-ups to make sure we had the right transitions between the curtain wall and the brick, but we also used that to look at the variety and say, hey, do we have too much or too little of that variation in the project? And I think we're pretty successful in having that historic character of the brick matching what you have for adjacent buildings, using my pointer here, along the warehouse, along Fulton Market, as well as stepping back that tower and the use of brick all throughout the edges of our building. We also utilize the craft. In this case, this is hand-set brick in our building lobby. Again, wanting to promote that material. We got playful with it with the 800 sign and rotating the bricks to create that signature move in our lobby. Again, a lot of exposed finishes, exposing the craftsmanship, whether it's terrazzo, that cantilevered slab right there, the concrete of the building, and definitely brick being highlighted in the lobby. Innovative structural solutions. We have a breathing brace in this project, and I'll talk a little bit more about what that means. This is one of my most favorite views of the project, walking into the building, looking up, seeing the bracing not really connect. Trust me, it does, but at this scale, it looks like it doesn't connect, and there's a reason for that. But building on, cross-bracing solutions we did for Hancock. I mentioned Mount Street again, where we actually took the cross brace, took the node, brought it up, make it high-waisted. We found that to be 10% more efficient than just a normal cross brace, incorporated the facade there. And then with the skinny plate between them, innovated on that and made it a signature piece of 800 West Fulton on both the east and the west of the building. You can see some of the details here, again, lifting up that node. And what this thin piece of metal does is allows the brace to move, allows it to breathe. There is a lot of thermal expansion and contraction that occurs, and this is kind of sacrificial as that occurs in the building. And then, of course, thermal comfort in the project as another technique to incorporate into building performance. You have to tune the facade to the building. And we studied a lot of different methods for mechanical. I'm sure most of us architects utilize VAV systems in our office space. But through all these studies, when we were looking at energy usage, energy costs, first costs, putting them in, maintenance costs, and life expectancy, we landed on VRF. Something not commonly done in the city of Chicago. I think this was the first office building done with this at any scale. And that took a leap of faith by our client, by ourselves, by our mechanical engineers to incorporate it. The tenant brokers, it took a leap of faith for them to understand what this really means to tenants as they fit out the space. But it was definitely, from the energy efficiency there, it was most beneficial to the project. It's much smaller. So we were able to limit the space allocated to mechanical. These are units put into our ceiling. We don't have ceilings, but these as packaged units were complementary to the design. So at the end of the day, we had a shared vision for the project with our client, talking about incorporating daylight, indoor air quality, access to nature with those outdoor environments, increasing mobility, smart infrastructure and resource preservation that then resulted in measurable goals. Net zero within 5 years with offsets, a 30 kTBUH per square foot per year, energy usage, almost 50% energy savings over ASHRAE 90.1. And we also, this was one of our first forays in really analyzing the embodied carbon put into our projects and limiting what we're doing and putting into our buildings. A lot of achieved certifications. We are LEED Platinum for core and shell. Well was important to this, achieving gold status. One of the first wired certified buildings hitting platinum. This is a very smart building. There's over like 7,000 sensors spread throughout that tells you when the gym is occupied, when conference rooms are occupied, when to change a light bulb, when to change the garbage and trash. But it makes for a very smart building and an efficient building as a result. So transition to the other project, and as you can see with 104% reduction, this is a net zero building. This is our University of Illinois Urbana-Champaign campus instructional facility. The university came to us and our developer client asking for a project that is just classrooms. The engineering campus at the University of Illinois is very popular. You'd name a discipline of engineering, aeronautical, electrical, mechanical. They have their own building on this campus, but what they don't have is enough classroom space. And we have we did a building that has a variety of sizes of classrooms ranging from extra large from 500 down to a few smalls that are in that 30 and 40 range. There's no administration, there's no professor offices here. It's just classrooms for the university. And we developed a scheme, again, 60 feet for that flexible classroom space. Those walls in the center can be transitioned as need be in the future should classrooms need to grow bigger or get smaller. There's a central spine for the public corridor there, and then, an offset core that we incorporated for those functions, as well as a few which is on the south, as well as a few smaller classrooms there. You can see the aesthetic here, the whole idea of less is more. There's a lot of exposed elements of the project, whether it's the polished concrete of the slabs, the express structure throughout the building, and even the ceilings. We have a radiant panel, but that's it. Everything else you can see up and see everything else that's going in the ceilings. We have a lot of inside out. What's happening on the inside of the building transitions to the outside. In this case here, this is the kind of steratorium, that study space that was created by putting an auditorium that transitions from the basement to the first floor, capped with this steratorium, which is a very popular space. I took a trip with my kids a couple weeks ago on a Sunday. The place was just packed with people studying in that space. It's great to see it utilized. But it's not just one technique to get us to net zero. Again, tactics we used and employed are reduced window wall ratio, radiant systems, low VOC materials, electrochromic glazing, and ground source heat exchange in that Bardeen quad. Highlighting some of the techniques again, the offset core. This is what that looks like in plan in today. Utilizing that brick material, strategically locating glass, and I'll explain where those spaces are here in a second. Again, on the top, that's that 60-foot span of classrooms. We open it up to, on the east and the west, to fully glazed, and then to limit any glare, we have these strips of brick glass on the north to allow for some daylight, but yet the classroom functions to occur. That central spine, you can see stairs. We really wanted to incorporate and promote mobility, both horizontally and upwardly in that central spine. So providing glazing at the end of these spines, providing these openings for stairs, not only allow people to move, but you get a connection to those other spaces down below and up above as you're going up through the building. And then that hard-working core on the perimeter for toilet functions, elevators, some storage space, the egress stairs, as well as a few classrooms we were able to incorporate on that smaller size. And our window wall ratio, 38%, very tight. It is an engineering building. We wanted to show off the express structure. Again, limiting our embodied carbon. We're not cladding it. With that does come some challenges because you're taking that material that's on the outside, making those connections to the inside, but we did come up with some interesting and simple tactics to provide that thermal break with Fabrica pads so we could still express that structure while being thermally responsible. Passive strategies like self-shading, using the building to shade itself, whether it's the roof overhang at the top or the fact that we inset some of the spaces on the base to provide that shading, letting the building shade itself. Mentioned brick. This is a different tactic. I love what we did here with the load-bearing structural brick. Brick is a common material. It's required, almost required on the university, and so we knew we would utilize it. But being an engineering building, we wanted to do something different with this. In this case, we used a load-bearing structural brick for 3 stories, 4 stories, sometimes 5 stories. We have brick that is self-supporting. There's no shelf angles every floor. You don't see the flashing come out. With the use of reinforcement and grouting of cells, it supports itself for 5 stories. Now, we do have some connections back to the building for lateral, obviously. With those come the issues. We have some thermal breaks incorporated into that, but that's how we brought opacity using the brick material into the project. They have a university brick, but where we were adjacent to a lot of other structures that were more historical, we did a lot of tests with different color brick to make it complementary to the Granger Library, as well as some of the other structures there. Dynamic glazing, electrochromic glazing, the shading can respond to where the sun is in the building. And we utilize this both on the east and west. We use view glass, where you can transition from a visible light transmittance of 58% all the way down to 1%, depending on where the sun is in the sky. There are no shades in this building. The glazing does itself, and we did a lot of visual mock-ups with that. Strategic daylighting, similar to 8100 West Fulton. Yeah, we have glass in the classrooms. We definitely wanted to promote that central spine and those study spaces and that circulation space. But the stairs themselves, too, on the left of this photo, those are for purpose for egress, but putting natural daylight in there. All 5 sets of stairs are really active as people hardly use the elevators in this building because it is an experience. This is one of my favorite photos overlooking the Bardeen Quad. By the way, that's where we have our geothermal in the quad. But these spaces at the end become informal study spaces, very active as students are waiting for that next class in the building and utilized. And then finally here, again, tuning the building, tuning the facade to what we're doing for the mechanical systems. This is an example of one of the large classrooms. You can see the view glazing in the background of the image. The central spine is to the right, and then to the north we have that repetition of the brick glazing. But in this case, we have the radiant panels as our mechanical system. And what was important to this, obviously there's an energy efficiency to this, but it also provides comfort more so than a VAV system, where you may be hot or cold depending on the day by the glass and the adjacency there. But the radiant is a better temperature and a better for thermal comfort. So I know I ran over a little bit. I apologize for that, but thanks for letting me convey these two projects.
Lucas, thank you so much. That was an incredible presentation. I hope you guys enjoyed it. Everything from the UIUC project and sharing a deep dive into how you had it meet net zero objectives, to the 800 West Fulton project, which is incredible. Learning more about offset cores with inland steel, which is one of my personal all-time favorites here in Chicago. Anyway, thank you so much, Lucas. That was incredible. Next up, we have Tobiasz Staszak, Area Manager with Rainier's Aluminum North America. He will be presenting improving the living of people now and for generations to come with VR.
Okay. Hello everyone, my name is Tobiasz Staszak, and today I would like to explain to you how we approach facade design and engineering by utilizing virtual reality. But first, I know that some of you already work with Rainers, some of you heard about Rainers, and for a part of the group, we are completely new. So I'll take 5 minutes to explain who we are and introduce our company. We are leading European specialists in design and marketing aluminum solutions for the facade. There are other words to explain who we are, so let's go step by step. First of all, we are a family business, started in 1965 in Belgium by Jan Rainers. Jan started by designing, fabricating, and installing his own aluminum window door system. Shortly after, he was asked by other fabricators in Belgium, can you just focus on the development of the system? We really like it, and let us fabricate it and install it. So that's how the idea was created that Rainers will become a system house instead of a fabricator and installer. Unfortunately, he died 8 years later in a car accident. Martine Rainers, who's sitting here on your right, she became our CEO as soon as she graduated school, and she was our CEO until 2020. Now she's a head of board of directors. She's managing the company together with her brother and 3 sisters. They're passing the business now into the 3rd generation. So it's a fully family-owned and managed business. Martine built the company based on 4 pillars: innovation, excellence, loyalty, and respect. And I'll explain to you what's behind these words. So our mission is that together we improve the living and work environment of people now and for generations to come. We blend design, technology, and digitalization in innovative solutions that add value and inspire our partners. Our partners are fabricators, architects, developers, and engineers. Our motto is together for better. This is our world footprint, so headquarters in Belgium. We have offices in 40 countries worldwide, including United States and Canada. We have more than 5,000 manufacturing partners and the network in Canada and the United States. around 2,600 employees and annual turnover of more or less 800 million US dollars. This is the company's evolution basically since Martin took it over. And the revenue is of course generated by providing different solutions and products, wide range of products to our customers worldwide, including windows and doors, aluminum window doors, of course, sliding and folding systems, big range, anything from ultra-performing lift and slide systems to minimalistic systems to hurricane-resistant lift and slide doors, etc. And then facade solutions, unitized window wall, stick facades, etc. And a little bit about our business approach. So R&D, we have more than 100 engineers and designers every day busy improving our existing solutions and developing new systems. Each year we launched several new products into the markets. And part of our business, more or less 50-50 split, is standard and custom solutions. Of course, everything we introduce to the market needs to be tested and validated. Therefore, family decided 5 years ago to invest in our own testing facility, which today is the biggest in private aluminum sector. It's at our headquarters. That's where we do the air, wind, water testing, seismic movements, acoustical testing, cycle testing, entry burglary test. So we test every product when we introduce it to the market, and everything we sell in North America, of course, we have to retest and make sure it complies with local regulations like NAFTA and NFRC. We do this together with our partners such Intertech or UL. We have, like I mentioned before, we have a network of certified fabricators across North America. And the last part of our business approach is the partnership. So we don't only provide material to fabricators, but we actually build an ecosystem around them. So meaning anything from softwares to CNC machines to digital tools, trainings, etc. So it's a full 360-degree approach to make them more professional and to deliver better product for your projects. And we also work with, as I mentioned, we work with architects, designers, investors, general contractors. So we have a large library of tools available for you guys, such CAD, beam files, calculation tools, and Avalon. And now let me explain Avalon. But first, you will see it's been a massive investment, so I would like to explain why family decided to go for this approach. For more than 50 years, they were listening to their partners, working with their partners, listening to all the struggles, all the problems, all the issues that they've been dealing with. And then since now, technologically, it is possible, they felt obligated that we need to go for it. We need to take that step and deliver this solution. Also, facades nowadays, they're very complex. It's no longer a matter of putting something in the opening. Now we are talking about different products, new products, severe climate changes, thermal requirements, new building codes. Also, we work on projects when we see a lot of international teams where we have several different investors from different parts of the world. We see sometimes more than one architectural studio designing the facade. So we needed to find a way for everybody to get together and collaborate. So therefore, we invested in Avalon, our virtual reality tool. Virtual reality, it's nothing new. It's been with us for more than a century. It's a very simple concept. We have two pictures, one for each eye, and our brain combines it into the 3D environment. There is a lot of devices that you're familiar with. Probably some of you already used some of them. And for sure, when you think virtual reality, this is the first thing that comes to your mind. The problem with these devices is that it is very difficult to collaborate. Everybody is very immersed in its own virtual reality, and it needs a lot of guidance from someone. Therefore, our approach is the virtual reality cave, which is already known. Similar concepts are used in the automotive industry. The difference here is that we work with, we are in the cave, which you can see here, and we work with the see-through glasses. So you can, what I see is exactly what you're also looking at, and we can all look at the same detail together. And this is our cave, this is our meeting room, this is where project shareholders, stakeholders get together and discuss specific projects.
Welcome to Avalon, a space to explore architecture through a shared virtual reality experience. Did you ever wish you could walk into a building that is still in the design phase? Avalon can take you anywhere you want. 25 projectors make architectural designs come to life in unequaled resolution, with cutting-edge laser technology creating the most vivid colors, contrast, and brightness. Active 3D glasses create a natural spatial awareness, and as a user, you are instantly immersed in a true 3D environment that creates an incredible sense of scale and depth. You are able to share the experience with your partners, allowing you to discuss and evaluate your projects before they are built. Avalon is a collaborative working tool, offering a joint experience between architect, contractors, investors, engineers, fabricators, and Rayner's experts. Virtual reality is set to play an important role at all stages of the architectural process, from evaluating design options and showcasing proposals to detecting construction issues before breaking ground on site. Starting at the conceptual phase, VR has proven to be effective in exploring the relationships between spaces. VR gives you an immediate feeling of being inside the building. You can experience the impact of light on a room or evaluate the different interior viewpoints. The spatial realism makes Avalon an incredibly powerful tool to communicate design intent. When the architectural design is further specified, BIM files are effortlessly translated into VR, providing architects with even better tools to communicate about their choices and improve their designs. Enabling architects to effortlessly move between BIM and VR truly revolutionizes the way buildings are designed. Avalon allows you to explore your projects inside your usual design software. Its powerful main workstation handles 3D models produced in any commonly used software in the architecture industry. By tracking the visitor's movements, real-time rendering engines create the ultimate VR experience, from initial sketches through detailed technical models and realistic scenes. Before your visit, you provide the 3D model of the project. In consultation with the building team, the objectives are set and the model is adapted accordingly and prepared for VR. Different options can be prepared to compare several Rayner's systems, configurations, bespoke solutions, or specific design variants for your project. Avalon is perfectly suited to create diverse virtual mock-ups. You can make sections, explain complex technical setups, or examine specific construction details or project solutions. This new way of virtual prototyping reduces costs and increases efficiency drastically. The high-resolution real-time renders allow you to see every detail so you can experiment with different configurations, evaluate simulation or BIM data, and further improve your design. You are able to experience Rayner's systems up close and compare the different solutions for your project. Discover Avalon, the space where future projects become a reality.
Okay, so There are two reasons why we decided to go for it and why we work with it. First of all is to avoid mistakes. It's most of the mistakes are not very complex. They're easy to avoid if we look at them and if we detect them at the very early stages of the project. And the second one is the decision making. Like I said, now we see a lot of different teams, international teams with different backgrounds, etc. And it's everybody's looking at the same project from a completely different perspective. General contractor, architect, developer, they all have their own point of view to each detail. So it's really a powerful tool when it comes to decision making. We can perform 3 types of evaluation: the concept evaluation, technical evaluation, and high quality design. And I'll show you a few examples. So here's the design, the concept evaluation. The architect really wanted to just see the building, understand the building, and see how it blends into the neighborhood. Here's the technical evaluation, where yes, we provided windows and doors for the project, but it's not the reason why they came to Avalon. Our partners from Zaha Hadid Architects, they wanted to really understand. This is the stadium that was the main stadium for the last World Cup in Qatar. And architects really wanted to see and understand how spectators will feel watching the game. And the second topic was that the roof closes for the game. Before the game, they pump the air conditioning and they open it right before the match. So there is the maintenance bridge, and they just wanted to evaluate the safety of the workers walking on it. Virtual mock-ups. So of course, for each specific project, we do the performance mock-up, but before we get there, we can already review multiple visual mock-ups, and we can do all the necessary changes before we actually build very expensive and time-consuming performance mock-up. We can explain in detail very complex facades where, facades inclines in every possible dimension. So it's really powerful to understand all the details. Here's the very good example of the decision making. So it's a project in Netherlands. It's a high-rise building, and as we go higher, the wind pressure is stronger. And then, of course, we need to reinforce windows and doors. And we have a never-ending discussion between an architect and the developer. When the developer doesn't want to see the reinforcement inside, an architect doesn't want to see it on the outside. We bring them to Avalon, and then we put the building in a fair perspective, and architect can decide, okay, is it really affecting my vision or not? This is a project in Malta. That was also utilized for technical evaluation. The challenge here was that there was 2 challenges. One was that it's a very complex facade. It's a unitized facade, curved, with integrated sliding doors, etc. There is a lot of parts of the building where traditional unitized turns into the window wall where the balconies are. But also it was the biggest project in Malta being built. Now it's all completed. But the challenge was, okay, can we do it in Malta? Can contractors do it? Can what's the quality of the steel and concrete going to be? So in this case, we were able to show them step by step how the panel will be built, how the panel will be lifted, installed, and in case of any issues with the slab itself, how we will adjust it after. Project in downtown Brussels. It's also now completed, Quattro. Architect came to see the building, to experience, to walk around and to feel it. The general contractor, like I said before, we see a lot new materials on the facades. So we use like not only aluminum panels, but now we have a stone cladding, we have spandrel. So a lot of different products, a lot of new products, and they really wanted to understand all the anchoring and all the details. This was more of a visual concept when in Netherlands we were joining the old existing school into the modern part. That's the airport in Dublin in Ireland, where we had to evaluate the stick facade, but it's bomb blast proof. So there was a lot of new details, new parts, new pieces, and everybody wanted to understand how the bomb blast facade will be fabricated and installed. And then again, back to decision making. Each project has, multiple concepts and options. So architect decided to go with to design what you see on the bottom level, and then we started making different models because there is always for the balconies should we use lift and slide system or a double door, single door, folding door, bigger glass units, smaller glass units, and again, general contractor has its own concerns, the developer has its own point of view. Okay, if we do bigger glass, what happens later in terms of breakage? How are we going to get this glass up there? So we make multiple different models for them. We show them how they work, how they operate, and then each one has its own pros and cons and a price tag, and they go all sit down together and discuss. Another example of the technical evaluation where it was a complex facade, and there was a very interesting conversation between a facade contractor and architect, because there was like, do we use smaller profiles, bigger profiles, and what's the price difference? So that was also very helpful for them. Here's the retrofit project, and also example how we utilize Google Earth. So developer wanted to really understand the impact of the light throughout the day, sunlight, of course. And the project was consisting a lot of, these used to be steel windows. So we replaced them with new aluminum window, and the developer wanted to see the impact of the light on the building. But what they noticed during this Avalon evaluation was that the depth of the reinforced aluminum system was basically not allowing them to see what's inside of the building at certain angle. So then they cut it in Avalon, and we had to redesign the reinforcement part. So of course, if this was on site, it would be much too far. We use Avalon to support our discussions in terms of product development. And also we help our fabricators to design their own facilities. So we do the layout for them, several different options. We invite them to our cave, and then basically they can walk through their facility before they start ordering machines, etc. So, to summarize, everywhere we go, we always hear that the successful project really depends on communication, collaboration, transparency. Our motto is together for better, and I think Avalon is the best proof of it. So, yeah, I invite you to bring your projects to Avalon, and please stop by our booth and let us introduce our North American team. Thank you.
How's everybody doing? Are you all still awake? Yeah. Awesome. Thank you, Tobias, for that fantastic presentation. It was interesting to hear how virtual reality is potentially impacting our design processes. So if you are falling asleep, you better wake up, because the next presentation is going to be a good one. We have Darin Cook, partner of Pelli, Clarke and Partners, here to present Salesforce Tower Chicago, as we know as Wolf Point South, harmonizing architectural expression in high-performance envelope. And I just want to mention, I met Darin this morning, and he's not only incredibly talented, he's the nicest person in the world. So everybody, warm welcome to Darin.
Thank you.
Good morning. Today we'll be talking about Salesforce Tower Chicago, and specifically the high-performance envelope and architectural expression of the building. We'll be talking about 4 major topics, which is the architectural expression and building form, unitized curtain wall, our lobby glazing system, as well as quality control. Again, we have some nice photos recently taken of the buildings. We wanted to share those with you. A little bit of background on the project. Salesforce Tower is the 3rd and final building within this multi-building project. It's the central tower flanked by 2 residential towers. The tower itself is 852 feet tall, 59 floors above grade, 3 floors below grade, with 1.2 million square feet of Class A office space. The master plan was started in 2010 and went through a whole series of evolution and changes across that sort of 13 to 14 years that we've been working on the project. Again, the first subject, architectural expression and building form, is really about, why does the building look like it does? And I think to start with that, we have to appreciate the specific site. Wolf Point, which is located at the intersection of the 3 branches of the Chicago River. And here it was actually captured in Daniel Burnham's imagination back in 1909 to really appreciate that sort of urban character of this site. Even in Burnham's earliest studies, he imagined a landmark or iconic form occupying the current site of the Salesforce Tower. This peninsula projects out into the water. In the middle of this dense urban environment, it's surrounded by water, but also has a great opportunity to capture views throughout the entire city. As I mentioned, Salesforce Tower occupies the sort of centerpiece of the site. And Wolf Point West, completed in 2016 by BKL. On the east side, on the upper right, is Wolf Point East, which we completed with Papa George Hames back in 2020, and finally completing Salesforce Tower just last August in 2023. Of course, no site is ever free of constraints. This one we had to accommodate the expansion of the Riverwalk, as well as accommodating a lot of underground parking for all of these residential buildings and the office building. But perhaps, I think more interestingly, we had some major view easements casting across our site from the neighbors to the north. This limited where we could place buildings, the width of the buildings, and the space in between buildings. So we needed to really accommodate our northern neighbors as we developed this entire site. What this ultimately ended up doing for our tower was the east and west sides became rather sort of sheer plains with a limited amount of relief because they measured the view easements right up to the face of the mullion. Early in the design process, we felt, this site with demands and an iconic presence, and we established 6 major design drivers that would really guide the design of all the buildings over time as they came online on the site. First was to respond to the specific context of Wolf Point, with amazing landscape and architectural forms. We wanted to step and frame the iconic towers of the central tower by setting lower heights for the 2 residential buildings. We were trying to maximize the distance between buildings, and at the same time minimizing the footprint, trying to touch the ground lightly so these buildings would make a more sort of urban and pedestrian-friendly environment at the ground level. Ultimately, we mandated a great deal of transparency at the ground level, and to bring back a level of detail from a pure glass building, we demanded sort of richly textured facade materials that are visible at both the urban and pedestrian scale. Our design response was to create sort of a simple geometric form, almost totem-like, particularly when seen from the sort of southern branch of the river. On the broad east and west sides of the building, we developed these sort of planar glass surfaces that define the overall form while greatly emphasizing the verticality of the building. And as we move up the tower top, we tapered setbacks and layered volumes to create a sort of striking profile as the building meets the sky. and as we reach the very top, we create a sort of a step crown to gracefully meet the sky. At the base, and back to this issue of touching the ground lightly, we actually carved away and set back the massing as we reached the ground. You can see sort of carving and recessed layers that ultimately created loges around the base of the south tower and open terrace areas with balconies on the east tower. And this also brings up the issue of the great deal of transparency. We're insisting upon as clear and as transparent ground level as possible to really capture the views and integrate the interior lobby with the park, the river, and the city views. The entire building is primarily a unitized curtain wall, and there's sort of 4 subjects I'll touch upon. One is the glazing, the color and character. Our mullion and fin details, our glazed mechanical louvers, and our tower top flutes. The entire building uses a VRE 159. We selected this for its color. It actually has a nice sort of silver blue coloration that we feel sort of reflects and plays with the ever-changing character of the sky. With that, we wanted to ensure that the building read as more as a monolithic form. So carefully balancing the opacifying coat on our spandrel glass was quite critical to make sure that the vision glass and spandrel glass were really sort of a monolithic treatment. Another feature of the glazing makeup is, again, looking for a very taut and flat surface. On the typical glazed unit, we made a 3/8" outer light thickness versus the typical 1/4. This was to get as flat as possible glass, which actually gives us a little bit more refined reflections and less bowing and pillowing that you might see in the typical glass. On the performance characteristics, they're here on the screen, but I think those really 3 main subjects I'd look at is the visible light transmittance of 53%. We're trying to maximize the amount of natural daylight for natural illumination and limiting the amount of electrical lighting that we need during the day. Also, the solar energy reflectance of 38%, trying to boost the amount of solar reflectance, also to reduce the energy loads on our mechanical systems. And lastly, I guess I can use this little thing here. Maybe not. Oh, there we go. Down here is the visible light reflectance. We're trying to balance the amount of reflectivity of the building to let it hold its form. At the same time, make the building transparent. We didn't want this to become kind of a flat mirror that became too abstract. So it's trying to find a balance between the reflectance and transparency was important for our design. The next item is the mullion and fin details. The entire building uses essentially 4 basic fins or mullion and joint conditions. The first is a butt glazed vertical mullions. The next is a 3" by 1.5" stainless steel clad mullion cap. The third is a 3" by 6" stainless steel fin or mullion cap. And then all of our horizontal joints are gasketed versus a sort of a horizontal expressed mullion. Just a little bit of background that drives some of the glazing sizes and some of the details. Our typical floor-to-floor heights are 13 feet, and because of that, our vision lights are 4'9", which are on our sort of a planning module for office space. So 10-foot high vision lights and 3-foot high spandrel glazing. The butt glaze occurs in this sort of purple area that you see running up the middle of the building. We wanted a very clean, smooth, and sharp kind of accent line running up the middle of the building. And this occurs what we call on the prow on both the north and south ends of the building. In the cyan blue areas is where we started to introduce these 1/2" by 3" stainless steel clad mullions. We couldn't go any further with the 1.5" with the 1.5" depth because we're kissed right up against our kind of view easement corridor, and trying to balance that limit as well as trying to maximize the floor plate for leasable office space. You'll see here that the typical mullions are 3" by 7", which is pretty much carried out throughout the building. as we move up the building in the green zones, as we sort of step back toward the top of the building, we're able to introduce deeper fins, giving us more shadow play, depth, and relief across the building. So, and that also gives us a nice bit of contrast of depth of mullions in the green zone against the very smooth glass down that sort of middle accent line of the butt glazing in the center of the building. As I mentioned, all of our horizontal joints are gasketed versus sort of mullion covers. These are also gray. We looked at a number of colors, black and gray, and we felt that the black had too much contrast with the silver, sort of silver blue glazing. So all of our gaskets are gray. This is the typical stack joint, chicken head joint, but you can see sort of the gasketing detail that happens at this horizontal condition. And even at the sort of mid mullion condition, it's also a gasketed joint with no horizontals, trying to, again, maximize the vertical reading of the building at every opportunity. We also happen to integrate the Meco shade system into the mullion to reduce any spatial impact on the inside as window treatments were accommodated. We also have glazed mechanical louvers. They're not quite louvers, but it's how we incorporated the mechanical intakes and exhaust in the building while not interrupting the overall building form. What we did is these are, we'll go to this detail. We actually have extra deep mullions, 11 inches deep at the mechanical floors. Offsetting these 2 layers of mullions allowed us to get plenty of our free area that we needed for air intake and exhaust. You can see up here on the levels 38, 39, those mechanical louvers while do not interrupt the basic form of the building. As we get to the tower top, we introduced what we call these sort of scallop flutes. This was kind of growing out of what we had established with Wolf Point East 2 years prior. And also it gives us a way to sort of transition and complete the building as it meets the sky. Those flutes, we used a 1-inch deep system, which gave us greater depth to get curvature and 3-dimensional quality out of the flute. And these happen to be clad in linen stainless steel, which is a sort of a textured stainless steel, which actually helps to diffuse the light and really help the reflection and the reading of the tower crown, particularly on a nice sunny day in Chicago, unlike today. As you mentioned, one of our earlier design issues was wanting to make sure that the ground level lobby was as transparent and as open as possible, really to opportunities to integrate the interior with the exterior. And so we actually engaged Syntec Architectural Systems out of Austin, Texas, to help develop this wall. While this is not a 40-foot wall that we've seen earlier today, this is a 25-foot glass wall. Unlike the wall we saw earlier today that is ground loaded on the floor below, this wall is entirely hung and suspended from the floor beam above. What that did was allow us to remove all of the mullions and fins right at the floor level. We wanted to be able to come up to the glass, place furniture up to the glass, and not have anything in your way. So this entire wall is hanging. I'll show you some of these details. This is at the mid-glazing joint. There's actually a concealed shelf angle that occurs within this 1/2-inch sealant joint, which carries the gravity load of the upper light. And the lower lights are actually hung from 5/16-inch diameter stainless steel rods, which go down and grab the bottom of the lights, which I'll show you in a moment. The system is made up of the exterior glazing, this detail right here. This is the stainless steel shelf bracket, which is again concealed in the sealant joint, and that takes the gravity loads of the glazing above and then transfers the lateral loads back into the glass fins. It's also made up of, whoops, go back one. There we go. It's also combined with several stainless steel patch plates, as well as, again, you'll see in a moment, the base channel and suspension rod that is hiding in the glass joint. Oops, I'm going in the wrong way. There we go. The exterior glazing on this, again, is not standard because this glazing is taking on quite a bit of structural stress. It's actually 1 13/16 inch thick. It's actually made up of all low iron glass to give us sort of the best sort of optical clarity and little green coloration. Also, again, just sort of making this as clear and as transparent as possible. So it's made up of a 1/4 inch low iron on the exterior, 1/2 inch airspace, and then 2 layers of laminated low iron tempered glazing with an extra stiff PVB. And that deals with any bowing or deformation which might happen in the glass panel. This wall is also on the same 4'9" planning module. So all the lights are 4'9" wide. The lower light is only 14 feet tall, and the upper light is 10'8" tall. Back to sort of the diagram of this wall is the glass fins have a stainless steel mounting plate that attaches to the steel perimeter beam up above. At the midpoint, right there, that again is where the little shelf angle is. It's taking the gravity load from the upper light, and there's a patch plate down here that I'll show you again in more detail in a moment. From that patch plate is where this concealed suspension rod is hanging that grabs the bottom light. So this is sort of the detail we're talking about, this sort of red element. There's a concealed plate and rod hanging down, and at the very bottom of the glass there's a support channel that is a leveling channel and also takes all the gravity load from the lower light into that piece and transfers it back into the vertical glass fin. So all the lateral loads are transferred into the glass fin, which sends the loads back up into the upper floor slab. And at the base channel actually takes off about half of the loading, lateral loading from the lower light, and sends that back into the floor slab. The other aspect of the wall we mentioned early on is sort of gray gaskets and gray sealants. It's a minor detail, but you'll see in the sort of glazing joints, we used for the wet glazing conditions a gray sealant. We already have about almost an inch of black from the glazing unit on either side, and we wanted to make these joints read as thin as possible. So we felt that the gray sealant actually created almost like a pinstripe, reducing the visual width and sort of dark line that would occur. So all of our wet joints are gray sealant, and again, all the gaskets are gray around the building. Ultimately, I hope this image tells you how or shows how this really brings the park right into the lobby. Lobby just opens right out to the outside, and this open loggia makes this a very engaging interior-exterior space. This is the entry to the building from up on Wolf Point Plaza, and you can again see that sort of transparent lobby below. Also talk briefly about quality control. I mean, many of the other presentations today have had some very cool animations. I don't have an animation, but we did have early on this multi-building project really required careful wind tunnel testing with 2 residential towers and this tall office tower. We needed to make sure that all of the residential spaces, pedestrian spaces around the building, particularly at the ground level, balconies, the pool decks, the open park, as well as the Riverwalk, would be free of any sort of undue wind loads and uncomfortable breezes blowing through the public areas. The wind tunnel testing also establishes the structural and cladding design loads as we went through later stages of the design. Of course, we did performance mock-ups. This incorporates, again, a 2-story mock-up, so we can test everything from story drift, deformation. This captures inside, outside corners. It has all of our sort of mullion details that can be tested to make sure they're not blowing in the wind or racking in the wind. And primarily, as you all know, this is really a chance to confirm that the entire assembly, as designed and detailed, meets the performance requirements, specifically for water and air infiltration, but many of the other design engineering drivers as well. So I don't have an animation of that propeller going, but this gives us a chance to do a dynamic spray test with the spray rack, water rack, with the wind propeller. The floors have hydraulic pistons that are able to induce racking to test that, and then over a series of days, the entire chamber undergoes thermal testing to see how buildings change under expansion and contraction under a range of different temperatures. And of course, we do visual mock-ups. We're sort of to get final sign-off with our client. We did a mock-up on site where we were still, even at this point, evaluating different glazing types, wanting to make sure that it looked, what we see, our office is in Connecticut, what we see in the sky in Connecticut, and how it looks here in Chicago is consistent. You can still see there's actually 3 or 4 different types of glazing here, where we're also testing not only the primary vision light, but properly matching that spandrel glass to, again, make sure that the glass reads consistently across the entire surface. This also has the various mullion details that we are looking at with the stainless steel cladding on them. All the horizontal gasket joints and sealant joints as well are included in that mock-up. Standing inside the chamber, we're able to, again, evaluate glazing character and quality from the inside as well as the outside, and ultimately making final decisions on, are we happy with the, mullion color and how that blends with the stainless steel nosings on the exterior mullions. And the middle photo happens to have that little detail we really like, which is the sort of integrated window treatment pocket for the Mecco shades. Again, keeping that whole system as thin and narrow as possible, having little impact on the leasable space for our office tenants. And as many people have acknowledged, projects of this size and scale are incredibly complex. They wouldn't be possible without, great collaboration and teamwork. And I'd like to, shout out to our ownership group, Hines and the Joseph P. Kennedy family. Our general contractor, Walsh Construction, they actually built both Wolf Point East and Wolf Point South. Our curtain wall contractor, Harmon, who also worked on East and South. Viracon, also a return participant, and Syntec Architectural Systems, as I mentioned, who did our lobby wall. Our curtain wall consultant is CDC, and without fail, our great partner here in Chicago is HKS Chicago, who this project wouldn't have been possible without. So thank you very much. I hope it was quick, but thank you.
Thank you so much, Darin. We so appreciate you sharing details on Wolf Point South and the incredible high-performance facade. It's interesting to learn about such a prominent site in Chicago, given the 1909 Burnham Plan. Okay, so don't leave. I know everyone's probably starving. Stay in your seats because we have a really exciting panel coming up. As they set up, I'll just kind of give an overview. The topic is Uncommon Chicago Brick, Modernizing and Preserving a Classic Material. And as many of you know, if you've worked on an existing building, it's nearly impossible to match the brick, now isn't it? So they're going to share a lot of great insights. Our moderator will be the very talented Jay Longo, principal of Solomon Cordwell Benz. He'll introduce the panelists, several of which, hi Brent. Great panel here. So while they're setting up, one more thing, just a few housekeeping items, and then I'll hand it over to Jay. 1 second. Number 1, AIA credits can be signed up for at the end of the day at the registration table on 10, so be sure to get your AIA credits. Don't leave without them. And finally, the venue asks that you do not bring lunch into the symposium here on 9. Coffee is fine. So again, welcome, Jay. I'll let you take it away.
Thank you very much. I'd like to bring my panelists out. Yeah, just come on all out. Great. So I'm Jay Longo. I'm a principal at SCB. And I'd like each of the panelists to introduce themselves. We'll start with Will.
Hello, everybody. Happy to be here. My name is Will Tippins. I'm Senior Director of Planning, despite what it says on my resume, at Related Midwest. We are part of the related companies out of New York, and happy to be here today.
Morning, everyone. My name is Brent Schmidt. I'm with Bricks Incorporated, and I'm in architectural sales.
Hello, everyone. I'm Krista Weir. I'm Associate Principal and Director of Preservation at Harshman Plunkett Architecture here in Chicago, working on preservation projects and new construction projects across the country.
Thank you. I'm Joshua Friedland from Bully & Andrews, and I'm Director of Historic Preservation.
So great. We're going to go over a couple different things related to brick, historic preservation, some adaptive reuse, some large-scale examples, and then some smaller sort of inspiration projects for you this afternoon. And I know we're standing between you and lunch, so we'll be brief. So first, I'd like to just start with a project story and have Will kind of introduce Lathrop Homes, which is a great example of an existing, early 19th century project that went through quite a bit of historic preservation. Will, do you want to tell us about this?
Sure, thanks, Jay. So this is, you're looking at an aerial view of the north part of Lathrop Homes, which was built in 1938. It was one of the first federal housing projects, one of the original 30 throughout the United States. It is a part of the Chicago Housing Authority's properties. We were brought in over a decade ago to help rehabilitate it into a mixed income community. It had fallen into great disrepair, and we had the challenge and opportunity to rehabilitate these really remarkable buildings that, quite frankly, are unlikely to be built today with the amount of perimeter wall, the amount of light. Almost every unit has corners in it. And we had this amazing shells to work with here at Lathrop Homes. So now it is a mixed income community, and of course, we took advantage of historic tax credits here in the rehabilitation, in the lasagna financing that it took to get this project completed. As you can imagine, one of the great challenges of a property like this was the rehabilitation of these traditional masonry facades, which were laid up with brick on the front face, clay tile backing. When they were originally constructed in 1938, in fact, the windows were constructed right into the masonry as they went up. So the steel windows were placed in the masonry, they built around them. The glazers came in and added the glass at a later time. The parapets were in disastrous shape at the time that we came involved. All of the lintels needed to be replaced, 100% lintel replacement, various spot repairs around. And as we just heard, the challenge, of course, is brick matching. These buildings, there were actually two types of brick that were used among the 15 buildings on the site. And we worked hard to come up with a modern day match. It took us 13 separate mock-ups of the various brick blends. There was no single brick that would actually work. We finally got to a group of bricks that would in fact match the various blends in this fairly, what people like to call Chicago common. It is common, but there's nothing common about the clay. It changes from batch, from source, from everything. So it is not something that it's like, oh, well, that's easy. That is a Chicago common, and you got it right from the beginning. So this we thought was a great property to bring to the fore. It really has a remarkable history. We've been delighted to bring it back as an award-winning mixed income community. There is an entire second campus of Lathrop that we are actually going to be closing on the financing early next year, and looking forward to bringing it back online as we did with the North Campus.
And sort of an adjacent property, it's interesting the Rosewald Apartments had very, very similar styling and was from the same era. You had the same kind of issues going through for this project. Our expert from Bullion Andrews probably knows it well.
Yeah, and I think it's just one of the things that is always an ongoing debate on preservation on brick is salvaging brick versus buying new brick, right? There's the color, the weathering that has happened over time, the soiling that has happened over time, and also the difference in sizes between historic brick versus modern modular brick, and marrying those two, and especially in a building like this where you have decorative brick patterns, trying to get those brick patterns to match when your brick is now 3/8 of an inch shorter. And so it's an ongoing debate, which is more cost effective, always plays a role, but also what's right by the building.
And Brent, you've had quite a bit of experience with these historic structures. Maybe you want to talk about some of the more uncommon units that you've had to restore.
Sure, so I think a little later in the slide deck we'll see the Roby House and a few others that are significant landmarks specifically to Chicago, but a lot of these architectural elements will be terracotta or brick or potentially stone, but on the Rosenwald, I'll never forget where the architect and the historic preservation consultant said it has to be 37 little scratches on the brick. Well, the manufacturer said it's going to be 45 because that's how we make it. So they ended up making it with 37 scratches because that's what it had to be. But the customization is not endless. It depends on the quantity, the scope of work, when you need it. So engage your people early on because it could take a long time to make the product that you want.
You want to talk a little bit about some of the more high-rise examples, especially like downtown, in terms of the brick blends that you've seen, Brent?
Sure, so I think we've got Old Colony Building, we've got Pullman. This one has a bunch of terracotta elements on top of the window heads that need to be replaced when the windows and the lintel systems were being replaced. The one on the left-hand side, that required a radius brick, which from center line to outside of the face of the brick was established. And then the manufacturer is able to provide a shop drawing to the architect, to whomever is the decision maker. Knowing the scope is very important to everybody on the team because the smaller the scope of work, the harder it is to get to someone to do it bespoke or custom. Instances like this restoration hardware project, I think that's a Booth Hansen project. There's the Old Colony Building again. The Old Colony Building, the size brick was Roman, which is very atypical for today, so we had to take a brick that's 3 5/8 inches tall and rip the height down to 1 5/8 inches, so there's certainly a cost impact on that, and then you've got to find someone that's willing to do it. So whether it's the mason subcontractor or your supplier or the fabricator, start early. That's the first thing I'd say.
What about glazed brick?
It's back.
It's back, yeah.
It's back.
Krista, I think you've got one in Tennessee that's
Yeah, we're using a lot
glazed,
of retail storefronts, black glazed brick, used in isolation. It's a beautiful product to use, and especially when you can touch and feel that product. I know it has its own set of restoration issues. It doesn't wick away water in the same way as traditional brick.
Yeah, and you know what I'm always looking at, whether I'm looking at a new construction project or a restoration project, it's just how my brain is wired at this point in my career, is how is it going to fail? And when it fails, how are we going to fix it? Because whenever I hear it's maintenance free, I interpret that as, okay, you're unable to do maintenance on it. And so like on this one, you can see glazed brick does have its unique challenges on the right-hand side. To me, it doesn't distract from it, but you see the chipping, you see the biological growth growing underneath the glaze, and then also typically glazed brick architecturally has butter joints, so they're very thin joints, and so being able to repoint it and do proper maintenance is always a challenge without causing additional chipping.
And then Brent, you were mentioning the bonding is coming back, the different types of brick bonding in our projects across the country. Want to talk a little bit about that?
Sure. So pretty typically, let's say your brick is 8 inches, you're going to lay 4 inches over the next 4 inches and so on. This is half bond. But starting mid to late 1800s until, we'll say 1950s, there were 40 or 50 different bond patterns that were used. Now architects are starting to specify that again, so Flemish bond, American bond. And there are some reasons which, Joshua can explain more fully why you would actually turn a brick and tie it into the next course of material when it's a double or triple wide. But predominantly now they're just aesthetic reasons to do so that you can make it look like the building was 100 years old. Textures, which we're seeing on some of these buildings, they're like tapestries, and new construction, we're seeing more and more architects learn about these patterns and these textures and trying to incorporate them to make the building feel like it's part of the fabric of the community.
Great, so let's talk about adaptive reuse for a minute. Krista, why don't you talk about what you've been doing in the historic district in Fulton?
Yeah, you can't really talk about brick in Chicago without talking about Fulton Market. It's one of the hottest neighborhoods in the city right now, and it's full of brick. So this neighborhood predominantly was built in the first 20 years of the 20th century. And it became a landmark district in 2015. So a lot of these buildings are protected under that landmark district, including most of the buildings you see on the screen today. Hartram Plunkard's office was over there for about 20 years, so I was able to work in this neighborhood for 10 years and work on almost all of these projects. What failed in these buildings was not the brick, it was the steel, it was the structure. These buildings were used as workhorses for meat packing, commission houses, so you can imagine all of the water issues for a building like that. So when the buildings became protected, we had to take out a lot of the structure of those buildings, where the brick was generally in really great shape. So if you go to the next slide, I have a project example, which is 1100 Fulton, home to Herman Miller's showroom now. This was a contributing building and in that landmark district. And you can see that the structure failed so poorly that we took out the entire structure and did what we call a facadectomy and supported that facade and rebuilt a new structure behind. And these are some nice finished photos of the addition we added that is 5 stories next to the 2-story existing building. We wanted to show you right behind me here some mock-up photos we did. We'll mention how many mock-ups we need to do to get brick matches. This building had a standard brick size, different from the modular brick size we use today, so we had to work a lot to make sure that the mortar joints were increased to get the brick to align when we were replacing brick. Unfortunately, this building, as you can see on the top picture, had a lot of brick that needed to get replaced to restore the building to its traditional aesthetics, and based on some historic photos we had, so we had to supply a lot of new brick here. So we worked with the Landmarks Department and Brent, and actually Josh's team from Bammer, to make sure we got the right brick for this facade. But it still looks industrial and fits into the aesthetic of the neighborhood, which is why a lot of people are attracted to Fulton Market, for that pedestrian scaled experience with such a textural material. Retail districts across the country really are attracted to this brick look.
And Joshua, maybe you want to talk a little bit about Chicago Common.
Yeah, so I brought this picture project up because of the name of the session, and this is a school up in Winnetka, a very prominent historic school, Crow Island, and currently there is a new addition being built, and so there's an idea of being sympathetic to the existing historic building to make sure the brick is compatible visually and matching, and so the goal is to match it as closely as possible. Obviously, that will be a new addition and it will be distinguished, and you can see having these mock-ups. This is the first round of mock-ups. To everyone's point about mock-ups, 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 sometimes my crews get very frustrated with mock-ups, 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 but it's important to make sure everyone is on the same page and setting the expectation. And so one of the things that I really emphasized, and this team, with the new construction side is really we have to look at the mortar as well as the brick. And so I didn't like these mock-ups in the sense that the mortar is the wrong color. And so mortar plays a huge outside impact on brick evaluation and brick performance. And so often we take that first blush of looking at, we'll get brick samples and it's just brick samples, and then you're holding up the brick samples and you're not including the mortar joints. And mortar makes up 10% of the brick surface, and it really has an outsized importance.
So let's talk about large scale. Will, you want to talk about
Yeah.
the row?
So we're actually back out in Fulton Market here. This is our building that just opened last year. It's been open about 9 or 10 months now, called The Row. And I think what we really wanted to talk about, it's a very interesting process as these buildings get designed. This is actually not in the historic district, but immediately adjacent to it. And one of the things that, and Krista was saying how, brick is such an important part of the Fulton Market area, as well as what people want in both the retail side of the world and the residential side of the world as well. And so when you look at large-scale buildings, they have sort of two very distinct ways in which they are part of the city. One is part of the skyline. And that has a very different view and a very different perspective on how it should be finished, what the materials are, what it looks like as it contributes to the skyline. But the other very important part of it is what's happening at the pedestrian level. And most importantly, why? Well, because of course you want to blend with the buildings, you want to be a part of the neighborhood you're in, but importantly, it's what people want to see, it's what people want to touch. I think one of the most important things about brick is it is truly an ancient material that everybody understands, everybody feels comfortable with. And when you are doing residential architecture, in fact, brick at the base of the building and brick is a part of that entry sequence. And Crow Island's a perfect example, designed by the Saarinen, that everything that you touched in that building was either brick or wood. And this is a really important part of considering how buildings come to the ground and how important brick has been literally since we've been building to the development of our sense of residential development. I think, do we have the next one? This is another one. In fact, there are some people here in the audience that are working on this one. This is our development at 400 Lakeshore Drive. It is now under construction. And again, it's a very, the tower on the right is nearly 1,000 feet tall. It'll be an iconic part of the skyline of Chicago. But there are when people come to here to reside in this place, again, it comes down and the building is in brick. It is the way that we transition to that pedestrian scale and that sense of residential development.
Very approachable.
Right. That's the hope.
Yeah, and then this is another large-scale project also adjacent to the Fulton Market Historic District, where we're utilizing brick at the podium and the retail area. And the way that we're designing brick walls has changed a lot over the 100 years. We're no longer doing mass walls, we're doing veneer walls. So the wall can get so much lighter than it was throughout history. You can see how much window is compared to brick in this facade. And I think that the brick kind of has an endless palette of details you can use. We can turn to history for different types of brick. Here we're using kind of a curved brick, so it's kind of a Gothic verticality to it. And I think everyone is starting to do a lot of interesting details and pulling from different times of history with a lot more freedom than we used to have because the wall itself is not the gravity load.
Yeah, and speaking of that, this is a project at at 320 North Sangamon that SCB designed, where we used thin brick in a precast panel in order to get the profiles that we wanted on the facade. So this is a faceted facade of precast panels that we used a stack bond blend in order to get variation in the window system. So 2 of the mullions actually extend out beyond the precast line, and then 2 are sitting on the precast line. So it thins the frame visually. You get a knife edge, which otherwise you wouldn't get in a brick. And so when you look at the detail on the end, this was coordinated with the precaster. There are many different mock-ups in order to how to stack all of those joints, but it hides all of the precast joints, and it looks like a laid brick product. So a little bit about inspiration, and maybe Brent, you can talk about all of the different things that we're seeing coming back from the historic past.
Sure, so long and skinny is in vogue right now. So Peter Sumter, a Swiss architect, did a project in the early 2000s, Colombia, Germany, and he did 2 things. He did the long and skinny, so say 20-inch profile bricks, that's back. And then breeze walls or lattice walls, if you will, that's quite popular. So this Gensler project, I'm not sure if anyone knows where the Schubas is, the Schlitz Brewery Tide House. And then this is a new addition, same program, they have live music and entertainment in there. And then this is their brew pub side, but they're taking old techniques, diapering, you can see some perforations here, and they're trying to pay homage to it, but also do something new. So breeze walls and long and skinny, those are quite popular. And then as Krista mentioned, glazed products are very, very popular right now. So shiny bricks, that's a thing.
And maybe the story about the Roby in terms of the cut brick.
Sure, so I think that was prior to you being there, Joshua, but Bammer took a bunch of 4-inch nominal height bricks and then ripped them down to 1 5/8 inches because the original Roman brick, which Frank Lloyd Wright was very popular to use a raked joint horizontally for the bed joints and then a flush joint. So in this case, Bully and Andrews Masonry Restoration took all of the typical height utility size brick that we call in the Chicago market now and actually ripped them down to less than half their height profile because manufacturers, not every manufacturer makes the height that you wanted for this project.
And maybe talk a little bit about combining masonry materials themselves. So this is an example of a glass block that's actually mixed in with a modular brick to create a pattern, which technically is very difficult because they have different bonding techniques. They have totally different structural qualities between, but the fact that you can get light and transparency behind one and the other, and the fact that they created a different pattern, it's really beautiful. You can kind of see that there is a vertical expansion joint between the 2 different walls, but it's done in a really, beautiful way.
Glass block is also back, if I'm just hitting on all the trends.
Glass block and glass brick are hot.
Yeah, they're all back. We're also doing a lot of lit brick and like interiors. I have a venue down in Nashville we're proposing to do a bunch of lit brick. So there's kind of exciting new bricks coming out as well.
Patterning. And then, Brent, you want to talk about some of the screen walls that you've pulled off in the last couple of years?
Sure, so the one on the right, that's Brooks Scarpa was the Starchitect on it, and then the local architect was Studio Dwell, Mark Peters. And inspiration for this was using a Chicago common brick, but in the center of the brick they wanted to put a dowel rod and then be able to grout it and then spin it at certain angles. The problem is when you drill a hole in a Chicago common, it explodes, falls apart. So we found a new manufacturer that was willing to make something and created a blend out of it. But I'll never forget, John Heckert was the architect on this at Studio Dwell, and he drew every single brick, what orientation it was spinning on the facade. So a lot of love was put into that project. And it's hard to see, but when you were to see it inside the courtyard, this is a single family up in Evanston. There's a courtyard there, and then there's a lateral bracing system. Louis Schell was the engineer record on it. And there's these little brackets that carry that central spire back to the lateral bracing system. And then we're seeing lattice wall incorporated into sort of like a spinning matrix, whereas the Green Line station, this one has an arts and performing mixed-use space on the inside. So we're seeing corbelling or portions of brick that are sticking out past flush. That's a very popular technique from 100 years ago. Now we're doing it just for aesthetics, not to actually corbel and carry weight. And then in other imagery, you can see that there's a bunch of perforations on the building on the left-hand side.
So with that, I think we're through our panel. I think what we'll do is we'll leave questions up during lunch. You can approach our panel then. So we really appreciate the opportunity to speak to you all today. Thanks.
So thanks again, Jay, Will, Brent, Krista, Joshua, for an incredible panel. It was so interesting. Thanks for sharing your insight on how Chicago common brick is definitely not common. It was really great to hear about your case studies, the Schlitz Brewery, Herman Miller Showroom, 320 North Sangamon, etc. Really quickly before lunch, would all session speakers please come to the stage for a photo? We'll have about an hour for lunch upstairs. Please don't leave us. Please come back. Also, please don't bring your food down here. Eat upstairs. We will see you in an hour. Hi, everyone. Did you have an amazing lunch? Eat lots of food? Are you geared up for session 3? I hope so. We have something really special in store, an amazing presentation by an amazing person, Lynda Dossey, who is principal at JAHN. She's not only incredibly talented, an incredible role model, she also has a very wicked sense of humor, so come say hi. She's also the president-elect of the AIA Chicago board. Yay! I literally sat by her yesterday and soaked in her wisdom. Anyway, today she is going to present to us what shaped the shape of 1000 South Michigan. So everyone, please give a warm welcome to Lynda Dossey.
Hello, everyone. So I have the advantage of having a tower that's nearly completed and just down the street. And so I'm going to tell you some of the forces that shaped the shape you're seeing here, which is unique. We did make accommodations for wind and structure and gravity and all those things. But what I'd like to talk about today is some of the more unseen forces that we deal with when we do these designs in working with other partners. Partners like our owner, developer team, authorities having jurisdiction, and in the case of this particular project, a little bit of force majeure thrown in. So I'd like to give some credit to our ownership team, which was Time Equities, JK Equities, and Oak Capitals. Our GC was McHugh Construction for GC and for concrete, and we worked with CDC as our facade consultant. McHugh also brought in Anthony Cinnamon, who presented earlier, who also participated in the keeping an eagle eye on the facade, and we worked with BVG Glazing as the facade contractor. So, having all those detailed technical conversations earlier, I'm not going to dive too deep into those. Because I think those have been well covered. Also, this particular project is a residential tower, and let's just say it was financially driven. So we did not have sort of the ability to pursue some cutting-edge technology on this one. We understood that to make it extraordinary, it would have to come from the shape and the design. So I'm going to tilt that conversation, if you will. So JAHN Architects has had a long and glorious tradition of form giving. We are very fond of doing our very volumetric, exciting, dynamic designs. But one of the other longtime goals of this is to also make it possible for you to look at our buildings and sort of read them, how they go together, what their function is, what they're doing. So we work at all variety of scales. We also have a history of doing skyscrapers. So what you're seeing here is the Xerox tower that was completed in the late 70s, not too far from here in the Loop. You're seeing 600 North Fairbanks, which was completed in the early 2000s in Streeterville. And you're also seeing the Cosmopolitan Tower recently completed in Warsaw with a very sizable overhang. I would also like to show to you this particular tower that's in New York City, recently completed in the early teens, called 50 West. This is in New York City at the bottom edge of Manhattan Island. It's very formal, very sleek, some nice curved glass on the edges. But I'm really showing this to you because our client for this project is the same one for 1000 South Michigan. So a lot of the conversations and collaboration we had with them carried over to our Chicago project. So 1000 South Michigan is just down the road. It's at the bottom edge of the historic Michigan Avenue Boulevard District, which is a lot of turn-of-the-century buildings with articulated facades. It is comprised of 3 different parcels that were merged together so we could maximize the FAR, and it has a remarkable view of the lake. So this is the view down the Michigan Avenue corridor, very historic district, lots of terracotta and stone and brick and heavily articulated facades of a certain scale. Down at the bottom edge, you can see the gap in the middle is the empty lot that our building is now sitting in. And it was sandwiched between a 6-story wood and terracotta loft office building. And to the north at 910 South Michigan is a high-rise residential building. And if you'd be keen enough to note that there are some windows to the units that are right on the lot line that we had the right to cover up if we really wanted. We did not. So one of the first influences on this building came from the site itself. Because it's part of that wall, we're not allowed any curb cuts. So any entrance to this building was going to be a pedestrian scale and a pedestrian use. So any access by vehicles to the site was going to have to be through the back of the lot, through the alleys, and off of Wabash. So we got going. We spent more than a year. I say that loosely, we, but I do have some former colleagues in here who did spend all of this time and working on all these different models, and we came up with very, very many models and very, very many designs. At the end, we decided to go big and epic. So 1000 South Michigan, 1,000 feet. So we put it all together, presented it to the planning department. One of the influences we had from the owner was to try and maximize the views, but also to maximize the square footage as you went up the building, so that the floors that would pull in the most revenue would be the largest plates. So that's kind of where the cantilever started from, to maximize the views and maximize the profit. We are cantilevering over 1000 South Michigan. Conveniently, our client also owns that building, so they were a very easy neighbor to work with. We went into the planning department. The design was well received in the public, but the planning department said 1,000 was a little bit too much. So we were sort of cropped down to a different height, and we settled in on the rest of the information. This sheet that you're seeing here, the bulk regulations and data table, I'm not going to deep dive into this, but I just want to let you all know that all of the architects in this room who have done high-rises in the city pretty much have one of these tables they have to work with. So I think it's a credit to our creativity that we have all the dynamic variations of high-rises that you're seeing today, but we all had to work off of like a one-page cheat sheet of requirements from the city. So in working with the city and redesigning the building, we had to bring the height down, and we negotiated the final height. We also negotiated the final floor area ratio, square footages we could build. And as it came down and down and down and got wider and wider and wider, it just kind of lost the same elegant feel. And it began to look a little bit lopsided and tippy. So we weren't as happy with the design, and the owner wasn't either. So we went back to the models, back to the ideas, back to some of the ideas we thought worked, and we came up with a new solution. So in this solution, we maximized the views facing the lake, and we maximized the floor plate, and we worked out a more balanced, elegant solution. We represented it to the planning department. They were quite fond of this scheme, so we moved forward with it. And we thought it made an elegant addition to the skyline when we would be finished. We then moved on and began talking with the landmarks department. If you're doing anything in South Michigan, you have a need to speak with the landmarks department to make sure what you're putting in will respect and reflect the rest of the street wall. The building we're in right now also went through that process here at Spertus. So they made several presentations also to the landmarks to work out the facade and the scale and scope of this building. We were no different, even though we were down at the tail end of the historicism. So a base was developed in the massing of the building that sort of carried through the step of the wall that was happening down there at our neighbors. Oops. And this was kind of worked out in collaboration with the different members of the landmarks department. Another thing we talked with them about was articulating the facade down here to better reflect the continuity of the wall. We weren't going to use brick or terracotta on this building. So what we ended up pursuing was oversizing the spandrels to be about the same scale as the typical spandrels you see along the historic wall, and then heavily articulating them in a mill finish aluminum to sort of get that sort of play and bounce of light and texture that the rest of the walls on either side had. We also played around with some of the operable vents in the residential units, kind of like a little bit of a play on a ribbon window, Chicago-style window. So we kind of came in with this sort of bumpy, textured facade that kind of was a play on its adjacent neighbors along the wall. We had also pulled back, you'll see, our north end of the building away from 910 so that they could keep their windows, but also so we could put windows in. And we pulled it back about 30 feet. But the landmarks had an issue with that because they needed to have visual continuity along the wall as part of the requirements of the historical district. So what you'll see, and I'm not sure if it's installed yet down there, but it's coming soon if it isn't, is a kind of screen that goes over this pedestrian walkway connection off of the park to keep the visual continuity moving across the wall. We also made full-size samples in the colors and the style and what we thought we would be articulating out of the facade, even before we moved on to a visual mock-up with the ownership, to present this to landmarks, to give them a confidence level, sort of a one-to-one scale of what we would be delivering. As part of all of this effort, we were rewarded with bonus FAR. But it came with conditions. We could only use it for residential. And we couldn't really add it back into the tower because we already capped out at the height. So a solution was derived to sort of mush around some of the residential and amenity FAR. And on our back deck terrace amenity, we introduced a kind of bar. And that is where we were able to take advantage of the additional FAR, which made the owner very happy and allowed us to achieve a little more area. So this is how we conceived of it under construction. So you can see we did not want to put the residential smack onto the amenity deck. So we created a amenity bar, and then we're able to put the units on top of that. I know I'm moving fast. They really want to give you a little time. So now, after we cleared landmarks, we got our bonus FAR, we now had to go in and talk to the building department and the fire department. And this is where the setbacks of the building come in. And this is where I'm going to talk a little bit about some of the shapes and the slopes. So at 910, as noted, we set the building back. We went up to the step of our tower and we began our tower. And so we tilted the tower out as much as we could until we hit sort of our setback limit and used that to help define the geometry. We may have played around a little bit to make sure it was pretty. At that point, we sort of pinwheeled that shape around and started to stretch the tower out as far as we could to the south to maximize the FAR and the units that would have views. But we're also, oops, that is the wrong button. But we were also sort of impinged by some code restrictions here of where we tilt over 1006. So we pushed it to sort of the maximum allowable angle per code, where we would not have to start putting in laminated glass. And we used that as the spring point to extend out over 1006. So with that angle over 1006, it brought on a new issue, and that is fire separation. So to have a 4-hour separation between the top of 1006 and our building, the easiest thing to do would have made the slope up to the height limit just a solid wall. But who wants that? And who wants to see that? So instead, a system was developed where we took the idea of taking the angled 4-hour wall and just tilting it horizontal over 1006. So what happens is we've got a huge concrete cantilever that gives us the 4-hour rating spanning over the top of the roof, just over the parapet of 1006. If you go down there and look closely, you will see it. You'll also see sort of the guardrail on it. The stair tower and the elevator tower that rise out of that roof were already rated 4-hour masonry. And so then we worked and put in a lid on top of that that would meet the 4-hour criteria to get our separation and to get our windows. And the Committee of Standards and Tests, the fire department and the building department, fortunately agreed with us. So the photos you're seeing here now is on your right is the underside of the formwork spanning over top of the parapet at 1006. And on the left, you are seeing the top of the concrete all poured. You're seeing the AAC 4-hour panels added to the top of the elevator. And you're starting to see the concrete wall that is carrying the upturned reinforced beam that's helping carry this cantilever. And this is kind of what it was look like after it was the facade was starting to go on. The next thing you'll see also in this picture is the setback floor. So this is the interstitial 2 levels between the top of the rectangular base that's creating the continuity in the Michigan Avenue facade wall and the start of the tower proper. And so I'm going to skip a little bit ahead and talk about the geometry of the tower. So what you're seeing here is the lowest plate and the highest plate within the tower. And so you're starting to see how far out the building tips out as it pinwheels out from the edges. We made the choice to curve the edge of the facade. That was something that the owner was keen on, to sort of smooth and round the corners. It was also something the design team did not hate. And so as we pushed this out, it was our idea also that these columns would slope out, but the structural engineer was less keen on that idea. So the columns, in fact, walk out. They're going for a stroll all the way up the building. This is something that we worked out between the general contractor and the structural engineer to make sure we were able to monitor and manage the deflections in the plate as it moved out, and also to keep schedule and use forms over and over again without having to make any special forms. So you can see the path and the journey each column makes as it walks out. And then we walk it out the distance that we were able in order to run the rebar through and overlap appropriately so that all the forces moving through triangularly are at an angle, but the columns themselves are vertical. If you go down there at first glance, it will look like they're sloped, but look a little closer and you'll see they're vertical and they're out for a stroll. Coming back down now to the interstitial floors where we have the setback. So you can see here giant terraces, and you can see all of the columns, and you can see how it all worked out. The north columns here, they go straight down, full height of the building right to the caissons. The columns at the south, they slope back over 1006 until we get back to the wall and our property line. The columns in the center go on a rather wild journey, and we'll talk about that again in a little bit. And then we have these outrigger columns that are, and shear walls that are providing the main stiffening for the tower. Those center columns dance around a bit, so they run up vertically through the base, behind the glass of the cut floor, and then they sort of transition out on the first couple floors of the units. The outriggers you can see here in this rendering, they actually bevel back into the geometry. We didn't have to transfer them, we just kind of had to shave them into plane. And so this is pretty much, we got all caught up, we were ready to work, we were ready to get going. We began construction and digging the caissons in November of 2019. And then March of 2020 happened. We got all the caissons in. We were getting ready to put the tower crane up, pour the foundation slab, and the world changed. And when that changed, the pro forma for the building changed. So the owner came back and said, we'd like you to turn this from a condo building into a rental building. And, but we'd like you to keep the design as much as you're able. So we set to work again. Fortunately, in the background, we were able to continue with our visual mock-up, socially distanced outside. We were able to continue with our performance mock-ups with just this tiny crew and mostly spaced out and mostly outdoors. And while all of that was going on, we began redesigning the building. So we changed the floor-to-floor height from condo market to rental market. We dropped the building down 30 feet from where we started, but we somehow managed to add 3 floors and maximize units. We came up with a new box score. And from here we went from 428 units to 738 units, provided we could make exactly 50% studios or efficiencies, which is another lecture for another day. But we dropped the building down to effectively 800 feet. We went back in, presented everything to the community again, to landmarks again, to the planning department again. So what you're seeing here is the before and after condo to rental as we tried to get everything realigned and going again. There's one more curveball here that changed the look of the building. And that was when we went up to 738 units from 428, we had to nearly double the amount of open space requirement for tenants on the site. That caused some changes. The first, we went scrambling to find amenity exterior space. Fortunately, that aligned with the new goals from ownership to make this a pandemic-friendly building, maximizing new spaces for tenants to hang out and feel like they had shared space that was outdoors. And also to find much more amenity, since we're going from efficiency units, we need more lounge space, we need more amenity. The amenity arms race, if you will. So we decommissioned the parking for guest parking in the back, turned it into a dog park adjacent to the Columbia Park. And we took over the level 10 roof and turned it from a roof into an amenity deck. And then the units that were in that recess, that cut floor, if you will, that would have been sort of mid-height penthouses with the most amazing balcony views of the park, became amenity lounges with shared terraces with the most amazing outlook over the park. And we were able to realize and capture those areas. We were also able to capture the next floor, and turn it into the building's own WeWork space. Since the world had changed and more people were working from home, we decided to add that as an amenity to the building. So all in all, in the change, we nearly tripled the amount of amenity space in the building that had been there when it was a condo to accommodate rental tenants. And one of the other major elements that we moved was we moved the fitness from the roof deck floor to take over level 3 and 4 that face Michigan Avenue. And by doing that, we were able to put more activity on the facade. So the changes for all this resulted in a very active and vibrant roof deck on the back. So all the towers in the areas, they look down upon this, they can see all this activity, there's no dead surfaces. There's no roofs not working or being active or used. And it allowed more intriguing views also for the tenants to experience at different levels, different ways of being within this building. So by moving the fitness down to level 3 and 4, we were able to add all this action and activity now on Michigan Avenue. Plus, as you're working out, you get a great view of the park. One other change that we made when we switched from condo to rental was to move from 2 separate elevator banks with 2 separate lobbies to 1 set of elevators and 1 lobby. And when that happened, we wanted to have the entrance on axis. So that center column, once again, we made it move. We split it and divided it around our on-axis entrance instead of coming through the entrance, creating a structural, easy to define, easy to read portal into the building. And finally, after we got all that resolved once more, we created this wonderful sheet in the set that's just nothing but the geometry of the enclosure and the cladding of the building. This is the recipe for all of the shapes of this project, which we shared to BVG, and then they got going and making sure all of the facade was going to line up. Now remember, they had a head start because we were already doing the VMU and the PMU as we were redesigning the building. So when we finally got the band back together, this is back on site in summer of 2021 with the developers, the lenders, the GC. This is just before the tower crane pad was being poured. We got going. So the foundation mat got framed up finally. We started coming out of the ground with the core, but then also with these great diagonal columns, creating a show for everyone riding the bus up and down Michigan Avenue. And the building went up very quickly once we got going, which a lot of people in this room, I think, have enjoyed watching it grow and develop and clad. And so now as you look at this building, hopefully you remember this very quick presentation I gave of how to read the building. You can see how the structure shifts. You can see why we made the choices we made. You know what this building is doing, why each slope and curve and moving column is there. But we're most proud that our original idea of creating an elegant structure that complemented our beautiful skyline was able to be achieved. Thank you very much.
Thank you so much, Lynda. That was amazing to hear about both tangible and intangible forces that always play in the design process, because as we know, design is never, ever linear. Next up, we have Ryan Ornberg, Associate Principal at Krueck and Sexton, the designers of our very beautiful venue, and of course, we all know Crown Fountain and many other projects. Also, Mark Chiu, Senior Associate at Thornton Tomasetti. They will be discussing facade repositioning on the Silvio J. Molo Federal Building. Please welcome Ryan and Mark.
My name is Ryan Ornberg. I'm an associate principal at Krueck Sexton Partners.
Hi, I'm Mark Chiu. I'm a senior associate at Thornton Tomasetti, where I lead the facade engineering group.
We're, of course, here today representing a much larger project team, but happy to walk you through one of our latest projects in the office. As you know, we're all happy to be here in the Spertus Institute. Our office has recently also completed, in the last couple of years, the CME Center at 1030 South Wacker, a lobby renovation project that we collaborated on with Thornton Tomasetti. And much of our current work in the office right now is really dealing with existing buildings. And what's kind of a current dialogue within the office is how we take a unique architectural position with each of these projects. When you work with an existing building, it has its own cultural and architectural value to it. So how do we really tap into that history and provide a new intervention? Today we're going to be talking about the Silvio J. Molo Federal Building. This is in New York. We're going to be talking about it today through the lens of facade repositioning and our design process for that. So it's located in Manhattan in the Civic Center, essentially at the base of the Brooklyn Bridge as you enter the city there. It was built in 1975, and it houses the United States Attorney's Office for the Southern District of New York. The building has essentially really exhausted its lifespan. All the systems are failing. It's actually a CMU block facade on it right now. Very little insulation, very little waterproofing from what we can find. So performing very poorly and in desperate need of a total rehab. The GSA set up the project to actually keep the existing structure, but we are providing a new facade for the building, new sustainable systems, and a whole new interior fit out for the United States Attorney's Office. And when we began working with the USAO, it became very clear that justice was at the core of their mission and was going to be central to the project. And when you come into Manhattan from the Brooklyn Bridge, you can see the building centered here in the photo around St. Andrew's Plaza. It's amongst many other government buildings, and the one directly to the right of it in the same facade there was actually built at the same time, same architect, essentially built as the same project. That is the MCC prison. And when we looked at the neighboring context, we began to kind of break it down into what these buildings represent, right? So you have the municipal building of the Dinkins, kind of the city services. We have St. Andrew's Church directly next to us. But we also have the Thurgood Marshall Courthouse, Cass Gilbert building, landmarked. And then we have buildings that represent enforcement, like the One Police Plaza for the NYPD headquarters and the MCC prison. So we began to ask ourselves, how do you transform a building into a symbol of justice? The current facade and the language of it really ties into those buildings of enforcement and doesn't necessarily represent what the USAO's core mission represents. So we looked at moving that towards more of a language of justice and relating it more towards the Thurgood Marshall Courthouse and having a vertical expression in the facade and more of a light-colored material palette. And so that set up the kind of general design concept for us. We had to essentially bring the whole facade down to the ground to, in part, protect the structure for protective design reasons. And then we also had to grow the building into the plaza to be able to create a new modern, secure entry pavilion into the building. And, you know, we really wrestled with this existing form of a building. When you have an existing structure, you can only shape it in so many ways, right? The chamfered corners were a real challenge for us, and trying to wrap a singular facade type around that proved quite difficult in just the reading and orientation of the building. And so we wanted to ensure that that connectedness to the plaza is kind of a civic presence, and that that entry really pulled through the front of the building and gave it an orientation, but also a transparency into that front face of the building. We then capped the north and south sides there with more of a planar expression that then relates back, you know, more towards a language of justice in the facade of the courthouse next door. So here you have the new representation of the building. And you can see at the plaza here, we were able to really provide a lot of new plantings and have security elements, but make it less obtrusive than the building kind of engages with the plaza today. Performance was always a guiding principle early on for the project. We worked really hard to reduce the energy use to about 74%. And then along with GSA's Green Power Purchasing Program, we're effectively a net zero building. We also maxed out PVs on the roof, and we're also looking at integrating bifacial PVs into some of the facade fins. And in terms of the facade, we really focused on making a thermally insulated envelope. Shading was part of it, but not as much of a driver as the thermal performance of the building. So working with the existing structure, we also had to expand the building program. They were very much out of space, and so we looked to fill in some of the lower floors of the building, shown in red here. And again, that also helped bring the facade down to kind of protect the structure of the building. We had to add the facade outboard of the existing floor slabs because we couldn't directly load the slabs. So we actually have to build kind of new slab edges, which also increased our area. And then adding the new security pavilion, you know, we effectively added more than a floor to the building. And then we also brought the entrance directly off the plaza, now making it universally accessible. So you can see the new pavilion here is approached from a visitor side. We have kind of a staff and a visitor side entrance that engages the plaza. And we were also able to create a nice garden space off the lobby as well. So working with the existing structure, we faced a lot of challenges just in the way it performed today. We had to bring it up to current codes with an offset core. We had some torsion in there that we had to add new shear walls, which are kind of at the face closest to us. That added stability to the building. We had to enlarge certain columns. Infilling those lower floor plates gave us area, but it also braced some long span columns at the foot of the building. And then at the notches there around the columns and that detail shown, we had to infill those with new slab to be able to create a consistent slab edge for our new facade. So while it took a lot of work to kind of bring the existing structure more up to what we're used to dealing with today, it still saved 55% in embodied carbon compared to building a new building. So the GSA, really set the project up with a good decision, which was, had financial reasons to begin with, but we were able to capitalize that for sustainability goals. We use low carbon approach for the interior materials as well. And also reveal moments of the history of the building with the exposed columns and exposed concrete waffle slab. We also have an existing Alex Katz mural that we were able to recenter some of the public spaces in the building around, and we're actually protecting that mural in place throughout construction. When we were considering facade materials, we also wanted to target a low embodied carbon approach. So we really focused on a zinc panel for much of our solid materials. And as well as the glass that we specified, we were able to put in a 20% reduction, which is kind of where the best performing end of the market is right now. And in keeping with this vertical expression in light materials, we developed the facade with these kind of north-south sails with a translucent etched spandrel and a vision glass, along with an aluminum fin, so that we could give the facade kind of a textured reading that kind of goes back to that the courthouse in the background there. And these sails are kind of scalloped along the facade, so the hope is that it has a lot of nice shadow reading and a rich texture, much like the landmark building. Whereas that west-facing facade is more transparent towards the entry. And then we developed the base of the building into the zinc panel that folds up to become the entry pavilion and is revealed at the entries with a wood slat. Because we have a lot of perimeter offices, it's an attorney's building at the end of the day, we were able to reduce the window-to-wall ratio by bringing up the spandrel panel to desk height and really focusing on just key areas where we needed glazing. Having more glazing at some of the chamfered corners of the building allows us to have more of an open office environment and drive the daylight into those spaces. But this illustration begins to show some of the intricacies of how you attach a new facade to an existing building and develop kind of a new slab edge detail there. And Mark is going to take you through some of the more details of that facade.
Thanks, Ryan. So I think this diagram here is a really good diagram to illustrate one of the biggest challenges and complexities for this project, where we had an existing structure that we began with and had to attach a new facade to it. And what we're highlighting here in red is a steel structure that was designed by our structural group, which we then interfaced with on the facade side, but it was a structure that had to be designed specifically for this project for several reasons. First of all, we had blast loads that had to be transferred and taken through this facade, and so those blast loads had to be taken to very specific points in the mainframe structure, and the load path was specifically designed through that steel structure, some components to fail, others not, so that the load path is as we designed it. And I'll talk a little bit more about that further in, but kind of just now thinking about the facade from a thermal point of view, we can talk about several different aspects of the facade, but I think what we're highlighting here in this presentation is the fact that we're targeting LEED Platinum, and because of that, and we're beginning with an existing structure, what we wrap this building in is a very big part of the design and to hit the target of a LEED Platinum building. And so while we didn't have much much push and pull. Of course, there's a bit of refining of the facade geometry. Really, what we were able to focus a lot of our attention and detail on was the facade design and the performance, and specifically in the area of thermal performance. Just a little bit of context as to the progression, the design, the thought processes of the facade and how we got from the very beginning to where we are today. What we had at the concept stage was 3 different facade designs labeled red, blue, yellow. KSP labeled them red, blue, yellow so that we don't imply favoritism by 1, 2, 3. And so that's why you see red, blue, yellow, and 3 different schemes here that were all kind of assessed and studied and analyzed to see what advantages can be taken from each different one, and then a peer review process that kind of critiqued these different designs, and decision-making eventually led to the blue and the yellow facade being the 2 that were pushed forward, and this is very early in the design. But then taking the blue and the yellow designs and understanding how they can perform thermally, because then, again, that's the story we're telling here, was a big challenge, and a lot of work went into it. And what we're showing here are the blue and the yellow options. What we did is we took 2 different facades from each option and drew the details, understanding how they would be constructed, built, fabricated, put together, but then throwing different variables at them to improve the performance, whether it's triple glazed units, additional insulation, playing with the stack joint height so that we get a deeper insulated area, and even one option where we were basically removing the opaque area from a curtain wall system and making it a continuous rain screen. So what we ended up with was a whole host of variables that we were able to assess and perform several thermal analysis on to understand where we are in order to hit the lead targets, the lead platinum targets, as I described, that we're trying to hit. Whether it was from a stick-built system to a unitized system, and just understanding the pros and cons of all of the different systems, all the different variables put onto those systems in order to understand that. And what we ended up with then was a way of selecting the different variables that we felt were worth pursuing, and that brought an advantage in the thermal point of view for our project. So kind of the different selections that we were able to make there. And what we ended up with, again, very early in the design, this was performed, and what we ended up with on the major facade, the north and south facade, was a system where we wanted to pursue this rain screen option. So rather than having a curtain wall system that has vertical mullions interrupting our insulation every 5 feet, what we envisioned was a continuous rain screen, uninterrupted insulation at the opaque areas, and really taking advantage of that. So what you can see here is a steel strong back system that we put into the design and implemented it in order to achieve that continuous rain screen, and also to then attach our facade onto. And that allowed us to get really high performance for this facade system. But now kind of tying the topic that I touched on earlier for blast, and as we started to kind of refine, sharpen our pencils and really think about how now with this design system, where the loads go and under a blast event, what we ended up with was a system that was attached to a steel frame that then tied back to the mainframe structure. And what ended up happening as we began to sharpen our pencils and kind of figure this out was that this steel strong back system that allowed us to achieve this continuous rain screen was actually too rigid and was taking blast loads in areas where we didn't want them to go. And so this kind of ended up scrapping this entire idea of the rain screen system, and we had to kind of go back and reimagine this facade from a traditional unitized curtain wall system where we have our insulation at opaque areas, but of course being interrupted by the vertical mullions every 5 feet or so. And so the interior insulation inboard of that became even more critical for our design, and of course we implemented it. What this also then meant is that we were able to look at what I'm showing here are all of the glazing systems, including the opaque portions of the glazing systems, so curtain wall systems that have opaque integrated into it, and the targets that we were able to hit with now this new designed facade system, which is basically a traditional curtain wall system, but kind of increased thermal performance. But what that meant then is, since we lost thermal performance in one pretty big area of our project, we had to kind of make that up in other areas. And so what we're showing here are the various opaque systems where we were really able to then improve, to kind of get back that performance and make sure we're hitting our lead targets. And one thing that we were really intentional about, or KSP in particular was really intentional about, is where we punch a hole through these opaque areas to allow views and allow daylight in, but being intentional about that so that we're not disrupting the continuity of this insulation and, again, taking a hit on the thermal performance. We have a very deep cavity at all of the opaque systems, again, because we're trying to get a higher performance from these systems, given kind of the knock that we got at the curtain wall area, unfortunately. And so what we're documenting here is the opaque systems, where they occur on the project, and the target values that we were able to hit with this revised design at the opaque systems. And you can kind of see here all of the different systems coming together, wrapping the existing structure and the various targets that we were able to hit. And as you can see, we're getting pretty good performance out of most of the facade systems, and we're able to hit the targets that we're trying to achieve LEED Platinum. One defining characteristic of this reskinning of this building is what we call the sails. And what you're seeing here in detail form are 3 of the sails that we have on the project. On the top left, we have a minor sail. What we have in the bottom left is more like a major sail, which occurs only at the 4 corners of the building. And on the right side over there, we have the parapet condition, which again, we wanted to read as a sail. What this meant was we couldn't infill that with insulation, because then you lose that translucency, that light reading through it, and that was really important for our design. What it also meant was we had cold bridges to the interior, which hurt us thermally, of course. And so what we had to kind of think about is how we can detail this in such a way that we reduce these cold bridges and make sure that we're not hurting ourselves, while we can get the facade to perform thermally from a U value point of view. Adding insulation isn't always the best thing, because then you may be increasing the risk for condensation. And we wanted to make sure that this area in particular, where is the highest risk for condensation, we weren't running into that issue. So with several analysis that we performed in 3D thermal analysis, we were able to kind of figure out the spacing of these outriggers that would essentially perform as thermal bridges, the detailing to reduce that, and how we're able to hit the target values that we have on the U value side, but not at the cost of having condensation. I think this was successful in confirming that for us.
So we're just wrapping up our design documents now and hope to go into construction soon. But you can see, we really took not just the facade as an idea of justice, but also the performance of the building and how do you be environmentally just as we aim for this to be the most sustainable federal building in New York. Thank you.
Thank you.
Wow, that was incredible. Thank you so much, Mark and Ryan. It was amazing to hear, well, first of all, to see these incredible diagrams, renderings, the thought process behind how you design through a language of justice. I find very interesting from both a sustainability perspective as well as the high performance facade idea. So thank you so much. Very great. Okay, next up, Brian R. White, Technical Section Manager with America's Insulating Glass, and H.B. Fuller will be presenting Realizing the Potential of High-Performance Warm Edge Technology in Insulating Glass. So let's welcome Brian.
Thanks. All right. Hello. Sorry, I got to get my throat moisture here. All right. So thanks. I've been watching all these presentations, and they've been absolutely fantastic, especially the slide decks. I mean, I can tell I'm in a crowd of people that are very capable and great artists, designers, architects. I feel like each and every one of you is going to be able to tell who the chemist in the room is based on my slides alone. So. Yeah, so I work for H.B. Fuller Company. For those of you that are unaware of us or have never heard of us, we are a global supplier of sealants, spacers, and adhesives for the fenestration market. And I'm going to talk a little bit today about why it's important, actually, as architects, designers, folks that are involved in the facade industry to look down into the IGs that are being produced and to look, all the way down, down, down into the spacer that's being used and the edge technology that's being used in that particular insulating glass. So the first topic I just want to introduce real quick is the carbon payback period, and I'm sure many of you are aware of what this is. Will Wild of Arup wrote about this quite a bit, but suffice to say it's essentially the point that there is a carbon cost associated with every design decision that we make. And that carbon cost is going to come in the form of embodied carbon, things like that. But suffice to say, what we want to do is we want to look at all these design decisions and try to emphasize those decisions that result in components that perform better for longer in order to increase their estimated service life and have less carbon costs associated with replacement. And at the end of the day, we end up getting a lower total carbon footprint for whatever project we're working on. So when I talk about total carbon footprint, I know, again, a lot of you are aware of this, there's two real main components to that. One is the embodied carbon of the system. This is going to be the cost of ownership of that particular project. So in particular, when we look at something like an insulating glass or glazing, right? A triple glazing, very good, is going to have a higher cost when it comes to embodied carbon than something like double glazing because of the extra glass, the extra spacer, all that kind of stuff. And then we've got the operational carbon, which is the daily energy savings that come along with that design decision. So going back again to the insulating glass, if we use triple glazing, we get lower HVAC costs, all the benefits that come along with a highly insulating IG unit, but again, at the expense of the embodied carbon. And we in the IG industry have done a really, really great job of reducing operational carbon and really addressing that operational carbon piece, but very much at the expense of embodied carbon. So when we look at that problem that we have there, that trade-off that we have there, we have to take a look at that and say, okay, well, what can we do given this set of conditions that we have? We've got a certain embodied carbon, that we're going to pay for this. What can we do to try to lower the total carbon footprint of this particular project? And what we do is we look at trying to ensure the longest service life we possibly can. So when we look at the operational carbon drivers for insulating glass, you've really got three main drivers. So you've got the low E coatings that are going to drive a lot of the performance and a lot of the solar control and heat control of the particular of the glazing. You've also got the insulating gas fill, which is another big driver in the insulating value of that panel, right? You've also got the edge system, which is really important because we tend to focus quite a bit on warm edge, warm edge, warm edge, warm edge. And warm edge is a great term, but really warm edge is just anything that performs better than aluminum, which is everything that's not aluminum. So when we say we've got warm edge and we want to consider the edge system, it's important. Yes, it is a conduit for thermal transfer, but what we want to do is think about how does that edge contribute to the overall performance of the IG unit. So again, when we look at that edge, we want to maximize the operational carbon drivers. We want to keep that low E coating intact, doing what it's supposed to do. We want to keep that insulating gas inside the unit, doing what it's supposed to do. So the longer we can do that, the lower we can drive the total, the shorter the total carbon payback period. You don't have to take my word for it. Work done out of the University of Cambridge, perhaps unsurprisingly, shows that if you double the life of an IG unit, you cut the embodied carbon in half. So pretty intuitive, but that's what it is. So when we look at that, we try to figure out how do we do this, and what we need to do is look at the edge seal in the insulating glass system, or in the glazing system. Now, I know many of you are very familiar with kind of the traditional box spacer system. This is composed of a hollow rigid box spacer, generally with a polyisobutylene or PIB primary sealant on either side of it. That primary sealant is what's keeping your gas in and keeping your moisture out. So the primary seal, in combination with the desiccant in that particular spacer, is really what's going to drive the service life of that IG unit. You're also going to have the secondary sealant in there that's protecting that primary sealant, keeping it doing its job for the life of the unit. But what we want to do is, okay, how can we reinvent that? How can we look at what that's doing? And what we do is look at TPS-based systems or thermoplastic spacer-based systems. So in this particular instance, we've got a product called CodySpace 4SG. This is a reactive thermoplastic spacer system. It replaces that hollow box spacer, the desiccant, and the primary sealant all in one. So it's really useful to think about it. I'm simplifying a bit, but it's useful to think about it as one really big slug of PIB. Being that it's reactive, it's going to cross-link with itself. It's going to build strength and build heat resistance. It's also going to chemically bond to the glass and the silicone in this particular, in the edge there. It's also very precisely applied to the glass using robotics, so it's easier to make a higher quality unit at the IG fabricator level. It's been used in structural glazing projects and high-profile projects since 2007, and due to that reactivity, forms that really permanently elastic and cohesive edge seal that stays where it is, keeps the gas in, and keeps that moisture out. We have validated this through external lab testing. So this would be European lab testing, which is 4 weeks of temperature cycling from -18 to +53°C with high humidity, and then followed by 7 weeks of high humidity. So one of these cycles is very analogous to like your ASTM E2190, your Canadian CGSB 12.8. This is what determines a unit to be, suitable for field service in Europe. We took units made with this particular edge seal system and ran it through 5 successive rounds of that testing. Mind you, 1 round is enough to approve it for use in the field. We ended up with low dew points, so there were no seal failures. The argon concentration remained quite stable, only lost about 4% over those 5 successive runs. But one thing that they do in Europe that we are not quite doing in North America yet is a test called moisture penetration index. And this is a test where you break apart a unit after the end of that testing cycle, and you measure the amount of desiccant that's been consumed in that particular test, or the capacity of the desiccant that's been consumed. So we saw after 5 successive rounds, or what's supposed to simulate decades and decades in the field, we found that only 12% of that desiccant's capacity had been used up. So stated another way, this unit still has about 88% of its estimated service life left, or its theoretical service life left, after what should be, what should correlate to decades in the field. We also compared the system to some of the existing box spacer, kind of the standards that are out there now. So aluminum spacer being your standard spacer, the hybrids and the foam spacer, the hybrids being kind of your warm edge systems, the foam spacer, which is out there as well. Running it through similar types of testing, we found again that the thermoplastic based edge seal lasted about twice as long, if not longer, than the industry standard today. So that has pretty important implications about what we can do with our calculations when we're looking into a total carbon calculation and pulling in the estimated service life of those IG units. So they're pretty compelling results, right? And we ask ourselves, why does it behave this way? What is it doing? And to us, and in the work we've done, it really boils down to the elasticity of the spacer system. One thing you'll notice about a hollow or a rigid box spacer system is that spacer is rigid. It can't move, it can't flex, it can't do anything. So what happens is when an IG unit sees its day-to-day, pumping, so high temperatures, low temperatures, the interior of that unit is expanding and contracting. As it does that, all that stress or all that stress that goes in the system results in that deformation. And usually what happens with a rigid system is the glass ends up deflecting. So we see pillowing, we see bowing out of the glass. Those are the types of things we see. Because that rigid spacer can't deal with any of the stress in the system, can't deal with any of the strain. So all that strain, again, goes into the glass, goes into the primary sealant. And if you remember me talking about the primary, that's what's keeping our gas in and our moisture out. So we'd prefer to leave that alone if we could. The thermoplastic-based systems can elastically deform, so they can move right along with the glass and then return to the shape they were in before that stress hit the system. So by improving that stress and strain distribution, you end up minimizing your chance of failure because there's less movement overall in the unit, and that translates into a longer IG service life. We've looked at this doing some computer modeling. So this is FEA modeling where we took an IG unit. We were actually working on a particular cold bent project here and bent a corner of that IG out of plane and then modeled the strain in the system. And you can see in the traditional box spacer system, all the strain is localized on the primary sealant. Again, that's what's keeping your gas in and your moisture out. When you switch edge seal systems to thermoplastic based, you now see not only a 10-fold less overall strain or absolute strain, so you not only do you see less strain, but you see it better distributed throughout the edge seal. So again, taking some of that strain and distributing it throughout the system. We also looked at this is a cold soak model. So we took an IG unit, subjected it to -20°F, and what we saw is the two panes of glass do deflect inward, which is what you'd expect for a cold or a closed system that becomes cold. But just by switching out the edge seal, again, now we see about 60% less deflection in the glass because of the ability of that edge system to take some of the strain out of the system. We've also looked at this experimentally. So we've taken we've taken a box spacer coupon here. This would be box spacer with PIB and silicone, and pulled it 2 millimeters out of plane, which is a pretty aggressive pull. Not, most edge seals aren't going to see that much movement, but it kind of highlights the capabilities here. And then we imaged the resulting strain in the system. You can see in the, I wonder if I can get fancy and use this pointer. No, I can't. Oh, yeah, I can. So you can see we image the strain in the system, and what happens is all that strain is concentrated on the secondary sealant. You actually don't see the primary sealant right now because it's been destroyed in this particular experiment. With the thermoplastic-based system, you can see it's there with the silicone. Pull it 2 millimeters out of plane. It stretches like a rubber band. Again, elasticity. When you let the stress go, it returns right to where it was before. And again, evenly distributes the strain throughout the system. So we might have learned a little bit about this building earlier today, and I have found that I very clearly need to update my statistics and facts about it. But a couple of case studies with the 4SG system. So this is obviously the Salesforce tower that we learned at quite a bit at length earlier today. Great presentation from Darin. IG fabricator here is Viricon, using the thermoplastic-based system as a spacer with Pelli, Clarke. Completed 2023, not 2022, but definitely one of the taller, more high-profile buildings we've seen the system used in. Also, the California Institute of Technology in LA. So this was the IG fabricator here was North Glass out of China with the Janney studios, is slated for completion here in 24. And interestingly here we've got about 20,000 square feet of IG being used in this building. And one of our landmark projects would be, and one of the very early, I shouldn't say early, but one of the earlier projects with this particular system, especially utilizing cold bent glass, is the Chadstone Shopping Centre in Melbourne, Australia. So this was a show glass, and the facade company is Sila. It was finished in 2017. This is the largest shopping center in the Southern Hemisphere, over 2,000 or over 2,100 insulating glass units on the roof, and is about a 7,000 square meter cold bent glass roof. And I really like the picture from the inside here. It looks very cool, but I really like to highlight the exterior picture that shows just what is capable, or what the system is capable of when you're able to bend it, you're able to do things with it that you are not able to do with a rigid box spacer system. So not only can you not do that with the rigid spacer system, but you can also do it durably and with a very high level of performance. So just kind of wrap that up. With TPS-based systems, you can really enable the most carbon-efficient facades out there. Given a set embodied carbon cost, again, by preserving that operational carbon, those operational carbon drivers, lengthening the service life, that leads to a reduced total carbon footprint and a shortened carbon payback period. It really yields industry-leading edge seal longevity, so that elasticity of the system is able to diffuse and reduce the strain throughout the system, which leads to really great gas retention and really great mechanical stability and durability of the units over time. And again, it's interesting here because this is one of the conversations we see occurring more and more often at the industry, at the IG industry level, is the Department of Energy and governments, starting to talk more about, less about what is the U factor of the IG, what's the U factor of the IG? Is it 0.25, 0.3, whatever it is? We're starting to see more and more conversations around, yes, but what is the total carbon footprint of the building? What's the total energy usage of the building? How does the building perform, not just the IG unit? So we think this is going to become a more and more important conversation over time, looking at, for example, the service life of the IG units. So, and with all these, we are able to power facades of the future, obviously using innovative techniques like cold bending, building integrated photovoltaic, LEDs within the buildings, things like that. The facades that are, really your imagination is the limit when it comes to using this type of system in your IG. So with that, I'd like to thank you very much.
Thank you so much, Brian. I learned a ton, I don't know about you, about edge seals and their impact on insulating glass and understanding operational carbon versus embodied carbon and the whole total carbon footprint. So thank you so much, very interesting. Next up, we have Ben Mitchell, Specification Leader, US Exalta. He will be presenting Embarking on Architectural Color Design Journey. So let's all please welcome Ben.
Thank you. Good afternoon. I'm here to tell you how pretty paint can be and how bad it can be. Many of you may not have heard of Axalta. Axalta's only been in existence for about 10 years. It formerly was DuPont Coatings. DuPont still exists, but not in the coatings industry. So all the DuPont coatings, the Imrons, all the DuPont coatings is now part of Axalta, including what some people may know, the NASCAR team, number 24, is Axalta, not DuPont anymore. Just real briefly, I've been in the industry a long time. I spent 6 years as a bench chemist doing primarily fluoropolymers, then went to tech service, was global tech service manager for about 6 more years, and traveled all over the planet, and then went into more of a management, technical management, and then on into marketing and sales roles where I am today. So when we look at what we do as Axalta, we look at your project excellence. Is a lot of what we focus on is learning how to help you make the right decisions with the right coatings. Continuing education, we invest heavily in education, both digital, in-person. We have tools that I will get to later that are self-directed, defining quality. And part of what I will get to here on the quality is a question I get daily, liquid versus powder. The AMA specifications, the durability, the warrantability, etc. We'll get into that. Then the color effect and finish, what you're looking for, what you're trying to protect, how long you want it to run. Project excellence, we look at our consulting role as not selling to architects, but educating architects and consultants, engineers, etc., on what coatings you are or you may need. There's a lot of variances in coatings, and how we can help you choose the right thing for the project and make it last and perform as needed. Workshops and seminars, we do, as I said, both in person and digital. Much of what we do is self-directed workshops that you can log into our system. You can go through the design phase, and I'll get to where we got BIM and other things other tools that we offer. Defining quality, depending on what are you looking for? Where is the project? What's your expectations? Is it coastal? Is it north? Is it south? Is it a southern exposure in the south? There's a lot of things to consider in what's the best coating. The most expensive coating may not be the best. You may need a more flexible one. A lot of our coil coatings are very flexible because it's post-formed to make building panels or composite panels, etc. So a heavy PVDF or Kynar, Hylar, whatever you want to call it, fluoropolymer, say, well, that's the most expensive, so that's the best. Not necessarily. Not necessarily. You may be spending more than you really need to, depending on where the project is. Sustainability, obviously that's top of mind is sustainability. And we have the first manufacturer to have a bio-core, we call it, made from bio-waste. And we do have certification that this bio-waste we are using to produce coatings do not interfere with the food value chain. These are post-consumer where it's not. It will save about 25% of the CO2 required to produce a powder coating. This today is only available in Europe, but it will be coming to the U.S. as we continue to develop and work with this. And it is certified with the ISCC Plus. Here we'll get into a little more of the product details. Life expectancy is obviously a huge part of your durability expectation. Warranties, you're looking for a 5-year, 10-year, interior, exterior. What does it need to meet? If you're going with a powder, it has virtually no VOC emissions or volatile organic compounds at application, which will reduce your carbon emissions. You look on the other side, see if I can make this right. Yeah, there we go. Your powder coatings have minimal VOCs, virtually none at application. You look at your liquid coating, your traditional PVDF coatings, Kynar coatings, et cetera, that you spec, obviously has considerable. You go down to a liquid with a thermal oxidizer, where most of your extruder applicators, many of your toll coaters, have thermal oxidizers. These thermal oxidizers destroy the VOC. By destroying the VOC, it generates a lot of heat. That heat then powers the finishing or curing oven. So if you look at your CO2 emissions, your powder coating, again, is no VOC coming from it. The liquid coatings with a thermal oxidizer now is destroying the VOC. By destroying the VOC, that energy is fueling the finishing oven. With a powder, you still need natural gas to fuel the finishing oven. So the two, if you take the entire cradle to grave through application, including a thermal oxidizer, the environmental performance of liquid and powder are very, very similar. Then if you look at the bottom one, you're looking at anodized. Anodized shows a lot of CO2 emissions, and that is primarily because it has a huge electric demand, and that electric demand is primarily fed by carbon fuel power generation. It's coming from coal, it's coming from natural gas. In this country, France and other areas, it's a different math. But in this country, the vast majority comes from carbon fuel generated. So that's where your CO2 emissions come from, the power generation, not the plant itself. Looking at the color, effect, and finish, there's a lot of different projects that we do in liquid and powder, and we have the expert guidance to help you decide. Like I said earlier, liquid may be better in some cases, powder may be better. We go to market as one, including coil. So coil coatings, powder coatings, liquid spray coatings. Most projects have liquid and powder on them. Maybe the powder is the railings, or the powder is the interior components or column covers, while the exterior curtain wall may be a liquid PVDF applied at a vertical line somewhere. Then if there's any primarily composite panels, it's going to be coil. Could be column covers and other, but primarily when you get into coil, it's composite panels that are going to be used. Looking at the different colors, our digital library of colors, where you can go on, and matter of fact, I'll move up one. We get into the color design box. You can get on to our color design tool, where it will walk you through. We have BIM represented on there. We have different gloss levels. You can look at textures. There's a lot of different things you can look at in design. And you see we have color experience rooms. We have more in Europe today than we do in the U.S., but we have some in the U.S. and we're adding more, where you can actually come in and see all the colors. We have smaller versions that we put up in other locations, but then the actual room itself we do around the country. We have a variety of case studies that we can show, and I don't really have time here today to go through them, but we have a booth up in the back of the room. If you want to stop by, and myself or Tom or Greg, one of us, we can give you more details or get your contact information and follow up with any other interest you may have. Our Vibes trend, that's an annual magazine put out by our marketing staff, and it's all about color trends. And it looks at the psychology and sociology of color, why we choose what colors we do, and it has a lot of impact, and even internal. If you watch something like the NCIS series, all of the colors in their offices are oranges and browns and color. They're really colorful. Well, there's a reason for that. The sociology and psychology behind them coatings, there's a reason they don't use beige. All that kind of thing, as well as the trends, future trends in interior, exterior coatings. It can be logged on digitally. You can get a hard copy of it, but it's a really, really nice piece. So that's really all the slides I got. The only thing I will add, kind of what I alluded to, when it comes to, I hear every day virtually, liquid or powder, which is better? Why do I choose this? Why do I choose that? At the end of the day, paint's stupid. The only difference between liquid and powder is how they're applied. You can take the exact same resin chemistry in a liquid, make the exact same resin chemistry in a powder. It's how they're applied is what matters, and what suits your project or suits your particular application is what should dictate it, not just liquid versus powder, because there's ways and places that each one have a very, very strong benefit to them. So give us a call, pick up a card, come see us. We'd love to help you out. Thank you.
Thanks, Ben, for introducing us to Axalta Coatings. And now, can you believe we are at the last event here, the one we've all been waiting for? So excited to learn about this. So we will be having a panel, and we will be learning about the Obama Presidential Center, presentation on the design concepts, conversation about facade design and articulation of the museum tower, technical development, material investigation, all the things we love. Can't wait to hear about it. We have Brian Abel, project manager at Todd William Billy Steen Architects, and Jessica Young, principal at Heinges Consulting Architects Engineers, will be the co-moderators for the panel. So as they get set up here, give them a second and we'll introduce Jessica and Brian. So everyone, please give a warm welcome for Brian and Jessica. And of course, everybody else. Also, anybody up on 10, please come down.
Hello. I'm Todd Williams of Todd Williams Billy Chen Architects in New York City. Our studio is much more than just the two of us, and our life is very much a collaboration with our collaborators, some of whom are here today.
I'm Brian Abel with Todd Williams Billy Chen Architects.
I'm Jessica Young with Heinches Consulting Architects and Engineers.
I'm David Bott with Heinches Consulting Architects and Engineers.
So this will be a little bit of a conversation. I'm going to start with general ideas. These images that you see here are actually the competition images that Billy and I presented to the president now more than 10 years ago. Enable and Noble.
Oh, sorry.
Back up. Enable is what the president did as a young man, going to the community and working with the community. And Noble is what the president has done in ennobling the presidency and saying this is a presidency for all. So these were two ideas that related, but also in many ways oppositional. Storytelling, in a way, relates to the idea of ennobling, which is to inflate or enlarge and make stories about life and about the presidency. And story making is really to have every single person count and every person tell their own story. These principles, again, are principles that we set were behind the ideas that we gave the president. And then the next one was the singular, which is, again, the ennobling and the plural, which is enabling. And we had this idea that it should be both about a singular element and about a campus. So of the 7 competitors for this who finally presented designs to the president, I think this was very, very important. This is a campus. These three images are images that hold dear to us and we thought were related to the presidential center in some way. One is that we felt that the president was and his presidency represented a kind of beacon of light to us and of hope. We saw that these are hands of people in the studio coming together, or many hands that make a community. And then we saw this rock, which Billy and I have had for more than 10 years, maybe 15 or 20 years, that we got in Ethiopia, which had markings on it, kind of a rock that was a talisman. We took those ideas and we actually presented to the president two different schemes. One was in Washington Park and the other one in Jackson Park. Jackson Park here is the image of the 1893 Columbian World's Fair, where basically the entire park was covered with white buildings, all of which were temporary wood, and ultimately were burned to the ground, except for one, which is the Museum of Science and Industry. And that building remains today, much as the lake that exists there. Remember, this is a park by Frederick Law Olmsted, and Olmsted had this idea that this needed to be a park for all people, and that parks for all people needed to be places where people were active. The site that we actually were given and ultimately chose is this one, which had a 6-lane road running through it. Those of you from Chicago, and even I know very well that it was a pleasure to drive through the park very quickly, but it also was a way by which the road blocked the community from the lake. So in our scheme, this is the 19-acre site that we've dealt with. Our scheme, very briefly, next, Brian, is this. It included Cornell Drive. We actually, that was a small carriageway in Olmsted's plan, but this is the site we had. So all of the hard pavement there, we removed in our scheme, and we essentially moved the running track to further off the site. It's now next to the high school, for which it's part, and this became the site. The site has one element in it. Next, Brian. We call it the museum, and the museum is a tower. Those of you who've been down there will realize that there's a singular element growing. There's also a base, an area we call the forum, the library, and I'll explain that in a moment, a plaza, and then there are 460 cars and all service parked beneath the park. So it's a very sustainable project. We're looking for net zero, although it won't be achieved by creating that on site. What we see here is that there's a tower on the left, the forum in the center, which is an auditorium, a restaurant. There's an element on the right, which is actually a public library branch, and the presidential library portion where the president's books are kept. And on top of that is a botanical garden element. So this is a site where which is covering all of the buildings, which is really a public park for everyone. All of the buildings are connected below grade through courtyards. The president asked us as we developed this tower, what creates the shape of a tower? And of course, here we're in this Krueck and Olsen wonderful tower building that is shaped and formed. And we needed to explain to him, once we had the basic square footage deployed in the tower, that there could be different shapes. And he, always curious, saying that he once wanted to be an architect, asked us to explore shapes and to explain them to him. Ultimately, we arrived on one shape. Next, Brian. Which is the shape that we see. And then these are sketches that we made for the president that basically show that this is largely a solid block. It's an iconic element, and it's poured in place concrete, and we'll today begin to explain some of those elements. So these are different views. On the left here is from the southwest. The view in the center is actually from the east primarily, and the view on the right is one from the north. So it's a building with a vague figure of those hands together, the lantern or a human figure, and is brought together so it's the primary element within the park. Iconic rendering of the building as we will imagine it when it's complete. And if you go down there, you'll see that a good deal of the project is already in place. So Brian's going to take over from here.
I'll talk a little bit about stone. We looked at a lot of different types of stone for the project. Sorry, is my mic really loud? Sounds, okay. We looked at a lot of different types of stone as the facade developed. We were looking for something that was light in color, something that was, that had a lot of variation from both one piece to the next and also within any given panel. The search was narrowed down eventually to domestic stones and then narrowed down even further to granites. One of the issues with light-colored granites is a lot of them are very uniform. They have some different colors in them, but often it's at a very fine scale, and we were looking for something that had drama at a larger scale. We did at one point consider, the image on the upper left was considering mixing different granites on the building. But we found this stone called tapestry, which is a granite from New Hampshire, which was very figured, had a lot of variation from one block to the next. This is the quarry, and you can see, particularly in the image on the right, the variation, this kind of swirling figuration that runs through the quarry at a really large scale. But this image is sort of representative of the effect that we were looking for, which was something that was massive, solid, carved, but also varied within its body. One really interesting thing about this quarry is that actually there are two different types of stone occurring within it. There's the tapestry, which is the more figured stone that occurs in these big, large-scale swirls through a background of a more neutral granite that's called kittlage. And we wanted to use both stones. We wanted to get as much variety across the facade as we could, as well as to use all the material that was available. This is a panel cut from the border zone between the two. You can see the tapestry on the left and the kittlage on the right. And this is showing above the stone when it's dry and below when it's wet. One really appealing thing about the stone was that it has this dramatic change in character when it gets wet, and we really liked the idea that the building could change moods. In the end, actually, we found 3 different granites that had a lot of these characteristics. The one on the left is the tapestry. In the middle is a granite called Silver Cloud from Georgia. And on the right is one called Riptide from Maine. And actually, these actually had not only being light and figured in their own ways, but each of these had a situation where within the quarry there were stones of different levels of character to use. We didn't select the stone before it was bid. Actually, we went to bid with all of these 3 types of stones, specified all 3 of them. They are owned by 3 major quarry-owning companies. The one on the left is owned by Granites of America, the one in the middle by Bagnara from Italy, and the one on the right is owned by Polycor. So the idea was there would be competition between these 3 companies, price competition, rather than specifying just one stone where the supplier could essentially name their price. And then after bidding, the stone was selected, and it was the tapestry in the end that we went with. This is showing tapestry on the left, kittlage on the right. We wanted to use, as I said, all of the material that we could, use both types of stone. And the way that we strategized that was the tower, which is the more prominent, more visible public building, is clad in the tapestry, and the lower buildings, the forum and the library, that are more embedded in the ground and can be a little bit more quiet and recessive, are clad with the kittlage. Though actually we blended some of the one into the other in both cases, so the tapestry cladding has some of the kittlage, and you can see that in this mock-up, little portions of that showing up in the panels, and also the kittlage has little portions of the tapestry showing up too, so that it's not quite as neutral as it was showing up in this mock-up. And Do you want to say a little bit about this,
Well,
Todd?
here we are. We not only traveled to the quarries, we traveled to the place where the stone is cut, and we set up and understood in this particular case, we're in Wisconsin, looking at some of the early figures, and I was astonished by the way that one has to analyze the strengths of the stone. That is, that they are marked out with a magic marker, and then different pieces are cut and then analyzed for their strength. So we needed a stone that was overall strong. Granite is strong, but with these inclusions, it also created weaknesses in the stone. Ultimately, we're using very thick and large pieces of stone, so that was part of the selection process.
Yeah.
Billy in the background, me in the foreground, Brian somewhere probably taking this picture.
Right. Although we were working with granite, the very figured nature of the stone led us to specify and follow through with a very rigorous testing series. So this is an example of the pre-production testing that we were performing to understand the strength and design and the behavior of the stone. We were working with WJE, and they traveled to La Croix to select samples. They first performed some petrographic analysis of the stone and observations to understand the materiality and the minerals that are in the stone, and identified several different classifications of the stone that we wanted to test to understand their strength. Here you can see some of the outlines of the coarser grain leucosome elements, and you can see where the stone has striations in it versus where it's more consistent in that kittlage variation that Brian's been talking about. So we wanted to be sure we were selecting samples representative of all the features of the stone, and we did a very robust testing at the beginning of the project, and then have been continuing to follow through with production testing, so we understand how the stone behaves.
So it's not just only about the testing, which Jess has just discussed. Actually, it's about the beauty of differences. And I think that that's actually embedded in the stone. That's embedded in the earth. That's embedded in natural material.
Right, here's some more samples showing on this side of the screen, we see the more consistent tapestry stone, kittlage stone, and then the tapestry stone with the striations and the minerals running through it. We also, this is an example from the structural calculations for the stone, looking at the panel design. Initially, we designed the stone as a clip and rail system. Much of the subframing for the stone was outboard of the insulation. Ultimately, Cleveland came onto the project and proposed a traditional handset system. So the analysis included a continuous rail at the base and clips at the edges of the stone for wind loading. In this diagram, you can see where the span is the greatest, the red area is the greatest deflection stress on the stone, and that's due to the spacing of those clips. So depending on the project loads, we added additional clips along the edge when we have higher loads at the corners. And then this is an example here on the left. You can see the section of the wall as it's constructed. This was a on-site constructability mock-up, so it gave the opportunity for all the trades to put the building together before we put the building together, so we could make sure everyone understood how things were going to come together to be successful. And you can see the layers of the structural concrete, the waterproofing, the insulation, and then you can see the angle elements and the kerfs coming out to grab the stone through the cavity.
Yeah, it was a constructability mock-up, an opportunity, also a visual mock-up to compress together a number of different conditions that show up in the faceted geometry of the tower into one sort of compressed space. So we've got the outward sloping, inward sloping, the fold, and then this recessed window that you see here, which is a smaller version of something that we'll talk about in a bit. This is a dry lay that was done at the fabricator. The fabricator for the stone is La Croix Granite in Quebec. They're working with Cleveland Marble, who's the installer. This was done to look at the range of the panels for the tower, as well as how that range would be distributed throughout the facade. And the size of the panels, we wanted to really maximize the size that we could get out of the quarry blocks. They're 9 feet high and widths ranging from 2 feet to 4.5 feet.
It also gave us a chance to look very closely at the stone and find that there are some ferrous elements that are in some of the pieces and some inclusions that really didn't want to have as part of the stone. And so that was also part of being able to look at this carefully with a number of different kinds of eyes.
And this is the installation as it stands now. This is the south side of the building. This will be the future entrance to the museum. And the stone is going up, so if you drive by, you can see it happening.
Here we're talking about another aspect. When you make I think of buildings as architecture as being designed from the inside out. So the last thing is the facade. That much like people, where the facade is, and this is about facades, it's about our external skin. In this case, we felt that we wanted to have a portion of it that felt very much like plowed field and was quite crude, even as the stone was very varied, and there are other parts of the building that are quite refined. So this is a bas-relief section. At one time we thought these would be words carved into the building. Ultimately the president wasn't keen on that, and we've essentially been thinking about how do we make long bars of stone that would create shadows as the sun passed by.
So this is a mock-up that was done to look at those bars and the effect of shadows and how they would catch light. The idea is it's a texture in the stone. This was done with Cora Stone, a company in Wisconsin that we were working with at the time. And just laid it horizontally, taken from a drone to look at the effect as the light passed. The idea was, though, that it should be something that felt carved from the facade of the building. There was this idea of furrows, of cuneiform, of something that was carved into the body of the building. So this is a mock-up that was done a little bit later with another stone company, Champlain Stone in New York, just looking at different ways of getting texture out of the facade. Going back to the quarry, the way that blocks were traditionally cut out, the raw edges of blocks with drill marks, that was something that was very appealing. You can see one of these pieces here that's cut from the skin of a block. But this was just looking at a couple different textural approaches.
And how could we do this? Were we cutting the stone with a clean chop, like curbs are cut? All of this is quite interesting because each quarry has different methods by which they both quarry and also chop the stone or cut the stone.
And this was looking at, with Champlain Stone again, some different approaches to achieve this texture in a more cost-effective way at the scale that we wanted to see it. Looking at some machine-made processes, some handmade processes, some different ways of finishing the stone, trying to get a texture that would be not too precise and machine-made, and have some feeling of being done by hand without being sort of over-determined and over-designed, something that felt like, in some way, a remnant of the process of fabricating the stone, and also visible at a scale from a distance, because, this is a tall building and had to be seen from far away. And this is how these bars are actually being fabricated by Lacroix Granite. And actually this individual who's cutting it here, we think is the one doing all of them. There's a line drawn with a template on the side, a kind of uneven line that he starts with, and then he walks along and chips away at the edges with the chisel, and that creates a kind of a natural unevenness in the result. And then he flips it over and goes back the other way. We thought when we started this process that having somebody actually do this by hand would just be really cost prohibitive, but actually it's like half an hour or so for him to do each of these, and it turns out to be a pretty reasonable thing to do. We talked with the fabricator about different ways of doing it again once they were signed on, and this was the approach they wanted to take. Not only talk with the
fabricator, but the guy actually chopping the stone,
Yeah.
How much can we bite off? How quickly can you do it? Stood there for a couple of hours watching him, talking to him. Pretty interesting.
This was a visualization we did to look at the effect and how it would change throughout the day. The idea is that this should change as the sun passes through the sky. At some times of day, it'll be quite subtle, and at other times of day, more dramatic, depending on the angle of sunlight. And then this is that effect on that same mock-up that we were looking at earlier.
Yeah, so to achieve the bas-relief elements, initially we were looking at those carved stones as individual pieces, and each piece was mechanically fastened back to the building structure, which is something that we felt is really important to do with any element on a facade. We want to have it mechanically fastened back to building structure. But in working with Cleveland, they started proposing, they demonstrated how they could carve off these bar elements, and they proposed putting them onto the flat panels. And we spent a lot of time understanding what that connection was going to be and settled on an epoxy detail that you see them applying at the upper element. So in addition to the epoxy, we wanted to be sure there was that mechanical attachment. So we have back of stone anchors on the bar element that are then fastened through the flat panel. We also paid a lot of attention to the top chamfer edge of that bar. We wanted to be sure that when the facade was sealed up and all the rain screens was closed, that there wasn't an opportunity for water to sit on top of that epoxy joint. And for the potential of, we were concerned for the potential of freeze-thaw, spalling cycles if water was able to penetrate that joint. And I think then, and here you can see the final, or the installation that's starting to occur on the project, and the bars are installed on different varied size panels, but you really, it kind of disappears, the joints disappear, and you get a really great effect of it not knowing how the pieces are attached.
So there are a couple of other elements. Of course, there's glass in this building, and there are different ways of using glass. In fact, there are 3 really significant and different ways of using glass. Maybe, I think Dave.
I guess that's me. I get to talk now. So yeah, we were confronted with a few very large openings on this facade, and what we realized right away was that each one of these was like its own little problem to solve. How are we going to span this open space? What's the most effective way to do that? And what maintains the design intent. And so this drawing is kind of an example of some of our early iterations where we were looking at, we were kind of sketching literally ways that the facade could either be hung, to span a long distance, or maybe it's spanning a short direction. We're passing this drawing back through to TWBTA for their comments. It's getting passed along to Thornton Tomasetti, who is the building structural engineer, to understand what the reactions are on the superstructure, which is basically the exterior site cast concrete. And so this is just an example of that sort of process. And here you see kind of a detail of that. So in this particular opening, we're starting to talk about, okay, this system is hung primarily up to a horizontal kind of girt, which then catches the lower portion of this wall and transfers the wind load, laterally. Then you have a base-loaded kind of storefront area, and we're starting to talk about what are the sizes of these elements.
And the idea, just to add too, was that where at the ground, where people walk up to the window and look through it, we wanted as large expanses of glass as we could, with as small mullions as we could. So that was one of the drivers, wanting the glass to be more articulated above. That was one of the drivers to having this wind girt and hung system.
Yeah. And then here you see that same kind of diagram, and now we're starting to talk about what are the reaction forces on these elements. This is where the back and forth with the building structural engineer was the most kind of, I think, detailed, and we're talking about different types of loads, security loads, wind loads, just gravity loads, things like that. And, this is another example where, the proposal is that, we're creating this large open space at the bottom that Brian spoke about, the entryways. And then we have this kind of like almost Varendale-like truss suspended from the roof. And you can see above that this is exactly what's being built now on site.
Yeah, that if anything, is the example of the most typical system on the project. I would not say any of the openings are alike. They're all unique, but that strategy of the larger opening at the base and the hung elements above, as represented here in the performance mock-up, is maybe what you could call the typical system. But of course, each opening with its varied shape and size was engineered differently. This performance mock-up was undertaken at Gartner's facility in Germany. The facade was fabricated by Gartner in combination with New Hudson Facades and U.S. Architectural Glass and Metals. And we all had the opportunity to travel first for this visual review that we're seeing here with the bronze cladding on the exterior of the system. And then we did a full performance mock-up testing regimen, and the system passed very successfully.
These are a couple sections through these inset windows that you saw a smaller version of in the mock-up. It was a case of, because of what was happening on the interior, we needed an opening, but not a large opening, not a large expanse of glass, but wanted to not just make these glass openings a small cutout out of the stone facade. So they're inset, and then they have this faceted stone around it that expresses itself in a larger gesture on the face of the building. It's also a case where we had kind of one system that became many different unique conditions because we're negotiating between a vertical glass window and a sloping facade, which is sometimes sloping inward, sometimes sloping outward. So it creates a lot of unique geometry conditions.
Yeah, Brian, I would just add that in that diagram, you can see how, because of the geometry, the mullion behind the glass couldn't just be this straight kind of element. It had to sort of turn the corner at both the top and bottom to get out of the way of the stone and the other insulation and elements on the facade. That.
Right. And this is in a way kind of the eyes or the glasses of a person, you know, so that you have a shadowed overhang that helps to define and make the, you know, the eye in a way more vivid, as well as shading it. So punched openings are this type on much of the building. And certainly the tower.
Yeah, this is the first one being installed.
Now, up on the top of the building, we had an idea that there should be ornamentation, and we also imagined that because this is public space, we all facing south and facing west, we should have a sunscreen. So we were imagining the ornamentation of traditional buildings in Chicago, as well as traditional buildings as we know them, where in fact there is some ornamentation at the top to help to draw attention to that and to define the top. At first we didn't think about this actually being meaningful words, so we were simply providing a pattern that we thought would be interesting. And ultimately discussing this with the president and storytelling group, they thought that maybe this is a chance also to make these words legible, or these letters legible. So here, we make many, many models in the studio. Here, a young woman is putting up the illegible idea of an ornamental screen facing south and west.
And this was, as the idea became that it should be real words, it became a typographic challenge also. So we started working with Pentagram, graphic design firm. They were getting involved to look at the scale of the letters and how they would fit together. They brought up this concept of the ligature, which is a graphic design device whereby letters are connected together to create a single element, something going back to ancient inscriptions. And it became an ordering principle for turning this into a somewhat more abstract pattern. The idea was that these should be words, that this screen should have some embedded meaning in it, not that it should be completely legible because it wraps the corner, it's a very large scale, you'd have to get back a great distance to actually read it, but that the meaning should still be embedded in it. So it was still linked together to create this kind of abstract pattern. But these ligatures also became a strategy for providing some structure and turning this into something that could be linked together into a set of panels.
So in fact, this is a portion of the president's 50-year speech for Selma. In a way, the tragedy of Selma and the victory of Selma. So ultimately, we were trying to figure out what could this be, what could it mean, how could it be constructed, and how could it be actually a freestanding screen.
Yeah, and at this point we were looking at what scale. This was actually before the text itself was chosen in terms of exactly what that text should be. Looking at the scale of the letters relative to a person who's looking through from the interior relative to the whole thing. We had been working with Heinches at this point on structurally what these letter sizes, the size of the actual profile would need to be. So it was looking at the scale of the overall versus the letter itself, which also then informed what the text could be, how many words could fit. And this was the scale that we landed on. The letters are, in the end, actually, they're a little bit under 5 feet tall. And just one side note, too, and this is the actual Selma speech as it's going to appear. One little note, interesting note about the graphic design aspect. The font is Gothic. Gothic font is something that the Obama campaign in 2008 used very rigorously for all of their material, and then in their subsequent campaigns. So in the graphic design community, that font is very much associated with them, so that was a very deliberate decision.
And so, you know, when we were first starting to look at this, and it was more abstract, as you can see here, and we know where that kind of went, we were talking about stone-clad letters, and in keeping with the rest of the facade. And so, you know, at first it was, you know, we knew that the stone itself could not achieve these sorts of spans to create this screen wall. So at first it was kind of a simple idea of, let's just build this out of a steel armature and clad it with stone on both sides, and which would involve some very complex stone carving and a lot of sort of blind connections, and what ended up happening was the steel started becoming so big to achieve this. You know, I think the wall is about 85 feet, I think, tall. Yeah. And one of the criteria of this architectural criteria was that we didn't want to see supports, you know, behind the wall. We wanted the wall to kind of stand on its own and sort of float in front of the areas where you could view it from the inside. And this is a great rendering that kind of expresses that idea. So we really needed to achieve a large span, and to do that in steel and then clad it in stone, the elements started getting really big. And we were talking quite a lot at this time, and at some point it was kind of like, doesn't this just want to be a cast sort of material? Isn't that what it's sort of asking for? And so once that conversation started happening, we kind of started steering towards UHPC, or ultra high performance concrete, which is this Portland cement. Really, it's like a concrete. It's made of Portland cement, like most concrete, but there's no real big aggregate in it, and it's extremely strong, and so it achieves strengths of up to around, at least for our project, I think it's around 20,000 PSI, so, you know, about 4 times stronger than most concrete. And because it's full of these stainless steel fibers that you see in the image here, it's got quite a bit of tensile and flexural strength. So it really is a high strength kind of material that can be cast and create these letters. And so, yeah, this is kind of the section profile, one of the profiles that was being developed at the time. I don't know if you want to talk about that a bit.
Yeah, this is the profile that we ended up with, so that meets the structural requirements for the spans. downward on the image is facing the exterior and upward is facing the interior. So it was profiled so that the required structural thickness is on the outer side where you see the entire screen. But on the inside, when you're looking out, you see a narrower profile. The tapering also had some functional advantage because if you think about this on the horizontal, it helps to shed rainwater and shed ice. But also it creates a nice curvature to the shadows that fall across it and a gradation to the light when it hits it, which is what we were looking at here. Once that profile was determined, we did this mock-up to look at it at a full scale and see how it felt in the daylight. This is actually made of styrofoam. This was our first take on looking at it at full scale before we had folks who could make it out of concrete that we were working with.
The UHPC is much smoother, actually. So, when we were talking before about creating this long span, you can see on this image, there's kind of two middle lines of support that create about maybe a 40-foot open space with no support. And so when we looked at that, we started thinking of a cantilevered bridge design kind of turned vertically. So this is kind of the classic photo from the 1800s bridge engineering school in England where, these engineers are demonstrating the sort of concept of the bridge where you've got kind of two sort of diving boards sticking out and then you can drop in the middle element in the center. And what that does is it ends up creating a pretty large uninterrupted span. So when we're looking at that, we have to start really looking at what are the letters themselves, what kind of stresses are we seeing, what kind of deflections are we seeing, what kind of bending moment diagrams are we seeing, and this is kind of the classic cantilevered bridge sort of bending moment diagram, and what you see is there's kind of 2 points where you have almost no moment, and those are kind of natural hinge points where we decided this is where the panels can be broken up. So we have kind of an upper panel, a middle panel, and a lower panel, and where they meet, they're just kind of pin connections. So you don't have to rely on such a really strong connection between one and the next. And so, after we start thinking about that, the question is, well, how large can we cast these panels, how wide they can be? And it's really limited by the kind of shipping, how much can you ship on the road? And so it's really about a 12-foot, I think, maximum panel width. And so we started looking at these as, columns of 3 panels stacked on top of each other, about 12 feet wide. And so then it becomes a question of, well, how does this work with the text and the words and what are the load paths down these panels? So we started coming up with rules like, well, every column of 3 panels needs to have at least 2 load paths coming down. And in some cases, we ran into issues where, well, there's a big space in the words here, and we don't have what we need. And so then it became a whole issue of, where do we have problems? Can we shift letters a little bit, to make this work structurally? Is it still legible? I think you guys were working with Pentagram, right?
Right.
To kind of work that out. And
yeah, it was a very unique coordination where we're working on kerning and typography at the same time as a structural and material problem, which Pentagram talked many times about how it's not frequently that they get to work on a kind of a structural typeface. And then this is the panel division as it ended up with these 3 vertically stacked panels broken into these sizes that range from 8.5 feet to 12 feet.
And then we did this little 3D model to kind of demonstrate the how it would actually be installed. So you can see, you can put the lower panels in. The middle panel would be kind of temporarily supported while you get the upper panel in. And in the end, you only have, the 2 kind of intermediate supports and the thing actually stands up. This was kind of to demonstrate that concept physically.
There wasn't a UHPC fabricator or a precaster who had done anything like this before. So our CM Lakeside Alliance, working with us, identified a number of different companies who could potentially do it, and in the end, they hired 2 of them to do these full-scale mock-ups as a proof of concept and proof of capability of the company. In the end, both of them did the project, and one of them was chosen. And just to note, these are full scale, but actually each of these is a little less than half the size of one of the smaller panels. So that's just to give a sense of the scale of the whole thing. And this is the mock-up by the contractor who was chosen. It's actually a team of Schaffner Haney, a precaster, a UHPC fabricator from South Bend, Indiana, and Fine Concrete, a UHPC fabricator from Charlottesville, Virginia, working with Silman Engineering in their DC office, who have done a lot of work on UHPC. And then this is the current state of construction. Just to say again, our CM is Lakeside Alliance. It's a really, really complicated project. I think a couple of them are here today, and we're excited to see it coming up.
Yep.
That's it. Thank you.
Thank you.
Yeah, thank you, guys.
Brian, Jessica, David, thank you so much. This made my year. It's incredibly inspiring. Going back to the concept sketch of the ennoble versus enable, I think is just so powerful. Learning about the materiality, the representation of the building, everything about it. We so appreciate you presenting to us today. It's just amazing. So thank you so much. Another round of applause.
Well, I think you just saw a tip of the iceberg, a very small tip of the iceberg of the work to make this happen, and it really involved so many amazing people and so many people healing together that it's unfair that the 4 of us should be up here. We did play a role, but so many other people play crucial roles and do it every day, so it's amazing. Great treat.
Thank you. Just a second, can I request all the panelists to just stay? We have some trophies left. So thank you all for attending today's event. I hope you enjoyed our storytelling from our speakers and panelists today. Like I said, we've recorded this event. We'll share a YouTube link of all the presentations we've received permission to share with you. And I'd like to also give a round of applause for our event host, Lori. She was excellent. Thank you, Lori. Right. Those who need to sign off for the AIA credits, you can visit the registration counter on top. We also have some tea, coffee, sodas, and a couple of snacks being served until we meet next time around.